say is that, and I think is Federica, the picture is before lunch, after lunch. So please, after lunch, which is, I don't know how to go back. So after the lunch, before we reconvene for the afternoon session, we will take a picture. So please just remain around. And another important thing I have to say concerns the social dinner tonight, which will be in this restaurant, but the organizers kindly asked all of us to, as soon as you have a moment, to go to the reception desk and to collect your bracelet to come into the restaurant. So please, whenever you have a moment, you go there and you take your bracelet for the hotel, for the restaurant. And I think that's it from my side. So again, apologies for yesterday, but I will be here the rest of the week and enjoy the program of today. So I think I should now welcome on stage the chairs of session about new services and new communities. So please, Rossana, Otto, Jan, on stage to introduce your sessions.
Okay, good morning. So let's start with the first presentation. The first presentation is presented by Otto Lange and Jan Michalek, and is about EPOS on WP2 achievement during projects. Change the slide. Okay, during the project's final period. So the presentation is presented by Otto and then from Jan. So Otto, if you want, the floor is yours.
Thank you, Rosanna. Okay, I will have a brief introduction talk about Work Package 2 from the EPOS On project, which is about enhancing services for science. Later on, we will see interesting talks in the context of the same work package. So I think the real interesting content will be after this more or less administrative update about the work package itself. But later on, we will have the content-wise presentations. Oh, I have to use this one. Okay. Okay, what is this work package about? It falls apart into 3 different pillars. The first one, task 2.1, is concerned with enhancing the EPOS portfolio of services. This is also an important aspect of the EPOS science program. In fact, it concerns all 3 of them. The second one will be about the integration of new communities, new TCSs and stakeholders, in this case, working with the private sector. And finally, the last task is concerned with computational earth science and tools. I will take over for task 2.2 and 2.3. And my colleague Jan, I'm already there for you, Jan, will take over for give you some overview of what is being done within task 2.1, the extension of the EPOS portfolio. Good luck. Thank you.
Thank you, Otto. We'll just jump in for the task 2.1 to explain what it's about. It's, of course, enhancing the portfolio of the services in our platform. That's the way, on top of the current services which are provided by the existing thematic communities, we have this project to support new type of services or even possibly new thematic core services to be connected to the platform. So here in the task, we have 10 subtasks, which eventually was broken down into 20 different type of service integrations. So you see them here. I will not read through them one by one, but they are adding new assets into the platform. It's basically seismic data coming from geochemistry data from the Slovenian karst. We have also improving the geochemical data availability, and also connecting the energy test beds, which is actually first time coming through the MSL community into the platform. We have magnetotelluric data. We have completely new community, which is myography. We'll have a talk about that further. And also the world stress map, which is around for quite some time, but now it's being connected to the EPOS platform, also having the inventory of mobile pool instruments as a service so you can look around what is available. And then we have also elements related to digital elevation models and the very first surface of the crust to SVS30 to be integrated in the platform. We have also improvements in the GNSS from the GNSS community on rapid position calculations and also disseminating them, and also expanding the airborne magnetic survey throughout the Europe. So the achievements from task 2.1, well, we had the first deliverable, D2.1, to prepare the roadmap for implementation of new services, which actually is now being tracked through the EPOS ON implementation level metrics. I will come back to that. As the status of the Q1, which is ending now in March, we have some services. Thanks to implementation level metrics, we track the status and also the timeline when the activity should start and become integrated. So we already started with these listed here. So the magnetotelluric data and models, the myography that started, since they are completely new, it takes a bit more time to explain the whole procedures to get them on board with the processes we use in EPOS. Also for the world stress map, the map has been released, but now we need to integrate it as a service. Similar for the inventory of mobile pool instruments, and for MSL as well. This is just a sketch generated thanks to Notebook LM, which is the AI, which is basically extracting the information from ELM and putting it in nice infographics to show you what are the actually 3 level stages to get the services integrated. So the level 1 is the preparation planning, which basically started at the start of the project, and then each subtask define the timeline when they are kind of ready to move on to the level 2, which means starting the discussion within the TCS, how the service can be integrated, what are the requirements for the service, and to be compliant with the ICS system, which is the level 3. So the level 3 is the actual integration to prepare the metadata, to prepare the converters for visualizing them, the services in the EPOS platform. And of course, then it goes into the staging production, which also goes with the long-term data provision. So it needs to have not only that's like ending, the whole procedure does not end at the level 3, but then it's kind of continuous monitoring and running the services in long term. I believe that's all for my part, so I will give floor back to Otto. Thank you.
Thank you, Jan. I think we are in pretty good shape regarding task 2.1, and I'm still impressed by the picture. But I think you had help from AI. But anyway, okay, I'll move on to task 2.2, which is about the integration of new communities and stakeholders. As I mentioned, it falls apart in both having a focus on embedding new TCSs, as well as, in this case, working with the private sector. Yesterday, we had an interesting talk from Rui about the integration of the new candidate TCS, the built environment data. And all of that is being done within the context of this task 2.2. Important considerations within this task are the fact that we need to have guidelines and description of activities that closely follow the EPOS ERIC implementing rules. For whom are not familiar with the last term, the EPOS ERIC implementing rules in fact describe all regulations for instance, the embedding of new communities, the governance requirements, and all these aspects. So there is a strong framework that already stands for quite some years. And integrating new communities obviously demands that we follow that rules. Another aspect to consider is that in embedding a new community, both the technical and the governance dimension must be managed in parallel. Generally, this is a rather complex business, but in the case of built environment data, already expressed by Rui, it runs very smoothly. So we're very happy with that. Then regarding the collaboration with the private sector, we have the cooperation with the Krafla Magma testbed in Iceland. And generally the challenges and obvious lessons to be learned when working with private sectors are how are you going to track and define both the progress and impact when you collaborate with the private sector? And what about aspects of bidirectional data provision? How should we imagine and elaborate a framework which takes into account mutual engagement? This is really new for EPOS as an ERIC, and yeah, there are a lot of questions to be answered during that process. Then where are we regarding the task 2.2? There are already guidelines for the integration of new community. This is one of the challenges that I refer to. This is was the first deliverable for this task. And I want to paraphrase the advisory board who came with a very interesting, the advisory board of the EPOS On project, who came with a very interesting observation, namely that this integration aligns with an important discussion which runs at the EU level. They think the deliverable is detailed and really could fit as a guideline for other research infrastructures to follow in making strategic decisions about incorporating new communities. And therefore external sharing with relevant fora is encouraged. We were very happy with that observation because it clarifies that we are not focused with a view inside, but we really are doing things that are added value for the whole European research infrastructure landscape. Then regarding the status of the collaboration with the private sector, the Krafla testbed. Oh no, I'm still with this issue. Sorry. There are some things to be considered regarding the guidelines that were delivered as the deliverable, because what was lacking with hindsight is that we need additional KPIs for a precise measurement of where are we in fact standing regarding such integration process. This is an ongoing discussion which is now also taking place these days at this EPOS Days meeting. Then regarding the private sector, there is a science industry workshop planned at the World Geothermal Congress upcoming in June in Calgary. This is also the place where will be more discussion about the sort of framework, the first contours of a framework which is needed for working with the private sector. And very important also to mention is that we are dependent on the time frame for the KMT data provision, which probably will exceed the EPOS On project, because the first dwell being done by Krafla is planned for 2027, and it's still uncertain when we can expect a data flow into EPOS, because it's obviously dependent on the moment where KMT starts drilling. Then I'll move to the final task of this work package, which is all about computational earth science and tools. In short, it's about developing prototypes of selected use cases of the ICSD, the Integrated Core Services distributed in EPOS. And the main characteristics for this task are the activities are for a large part related to the interoperability layer between the EPOS E infrastructure on the one hand and cloud and HPC infrastructures on the other. We need to leverage existing scientific workflow and services to enhance the research infrastructure as a whole. Very important is to take care of the alignment with and the possible extension of the current EPOS architecture design. Also very important open question is how to manage sustainable partnerships where they apply. This requires both definitions on the technical, legal and financial aspects under which these prototypes for ICSD can make use of external infrastructures. And finally, also important for this subtask is maximizing the results coming from the projects DTGeo and GeoInquire. Then what about the status of this final task? Current achievements are that the relevant use cases are already identified and fully described, and a landscape analysis has been performed for the identification of already existing tools and codes available. The status, it's very good to observe that currently the EPOS architecture design does not need any update because it appears to be flexible enough to accommodate the ICSD use cases that were selected and described. The technical, legal and financial aspects under which these ICSD prototypes will run and the related external infrastructures will operate, that needs a fully elaborated framework. That's still under refinement, but there has already been a substantial progress achieved, amongst which an MOU with EGI and the access to computational resources at Cineca and EPOS Italy. And then finally, the DTGeo results are currently being transferred and GeoInquire results are upcoming. So I can finalize my brief overview of this work package with the observation that all three tasks are in very good shape and we are really moving forward when you compare it to what we have described in the current EPOS science program. And this is where I want to thank you.
Thank you, Otto. So I would like to welcome the second presenter, Katie Giuliacci, who will present the integrating the Euro geographic maps into the EPOS platform.
Okay, so good morning, everyone. I'm Katie Giuliacci. I'm part of the IT unit of EPOS. I am one of the metadata curator. So I will talk about the integration of Euro geographic maps into the EPOS platform. So Eurogeographic is an independent international not-for-profit organization representing the Europe's national mapping, cadastral and land registration authorities. Their scope is to facilitate the access to official, reliable, comparable and verifiable geospatial data provided by these authorities. So this collaboration, the idea of this collaboration start around 2022 and 2023, fostered by the TCS GNSS data and products. So in the end of the 2023, the idea of the collaboration was included in the EPOS ON framework. In particular, was included as a task in the WP5. So after the start of EPOS on 1st September 2024, the communication between EPOS and Eurogeographics increased. So in fact, in March 2025, Eurogeographics participated in the EPOS Days, and in May 2025, EPOS joined the Eurogeographics General Assembly. So of course, this collaboration provides mutual benefits. For EPOS, it's an opportunity to collaborate with a community beyond the solitary domain to promote synergy, for the development and the adoption of common approach, solution, and services. It's a way to provide new multidisciplinary and interdisciplinary use cases and services connected to maps and geospatial information, and also can open a new channel for training opportunities. On the other hand, for Eurogeographics is an opportunity to approach a new reservoir of users by exposing data in the EPOS platform, is a way to contribute to shaping multidisciplinary and interdisciplinary use cases and services. And in this case, that can be of use for the Eurogeographic community. And also is a way to offer open science and research data management related training opportunities focused on the EPOS platform as a part of the Eurogeographic training portfolio. So what we have done. So the EPOS IT team, so it means Manuela, me, and the rest of the team, test the integration of the Eurogeographic map services in the EPOS platform. We created a proof of concept, we completed it, and it works. Thanks to the fully interoperable data format and standard, the interaction was easy. It means that the future implementation won't require significant resources. So technically speaking, what we have is that Eurogeographics map are provided via OGC web service, and they provide in particular WMS and WFS. The EPOS platform natively supports this kind of layer, so in this case, no data conversion is required. At this point, we create the metadata description to describe the Eurogeographic web service using EPOS DKP metadata specification. And after the metadata ingestion into the EPOS catalog, the test environment was created to validate the integration and the interoperability. Now, I'll show you some screenshots that show this test environment, and here we can see how to access these maps in this test environment, of course. To access the maps provided by the Eurogeographics, we need to click on the map icon in the top right corner. If I click there, there will be a menu with the first box dedicated to the base map that are already present in the EPOS platform. And in the second box, we have the maps provided by Eurogeographics. If I click there, I will see a list of the maps available, and I can apply one or more of them on the maps of the EPOS platform. And for each map, we put also the logo and the copyright statement of Eurogeographics to give them the right visibility on the platform. And also there is a button where the user, clicking this button, can find more technical detail about the specific map directly from the Eurogeographics portal. So the next step will be, first of all, formalizing the collaboration through a memorandum of understanding. And from the technical aspect, we need to refine this test environment to be ready for a production deployment. So it's all for me. Can I make a comment?
Okay, so thank you, Katie and Manuela in particular. But my comment is just about the fact that this is, we are very proud of this, although it's still not in operation. So we are still working on that. So we are very proud of this collaboration with Eurogeographics because it really started like something, okay, triggered from the TCS GNSS. So please, if you have any other suggestion concerning possible potential collaboration with other organizations, just come to us and we see what we can do. So that was triggered by the TCS GNSS, just to say, okay, let's see if we can talk with these people, maybe do some training sessions together, because they have interesting data and maps. And then it ended up with this, which I think is something really, is an added value for the EPOS platform. It might be or might not be useful for users, but we believe it will be useful. So that's the reason we did. And it's really something that we started collaborating with an initiative outside EPOS, and we actually are now delivering some results. So my message is, again, if you as a TCS, our scientific community, would like EPOS to collaborate with an initiative that is delivering and producing the data that might be useful for us, just please, discuss this within the Service Coordination Committee, because we will be happy to do this kind of collaborations. And thank you again, Katie and Manuela.
Okay, thank you, Lily. Then I'm very happy to introduce you for the next talk to Salvatore Martino. He will talk about a new subdomain within the a new domain within the multi-scale laboratories TCS, namely the field laboratories, in this case from the ground instability data. And I wanted to recall that the discussion of inclusion actually started 1 year ago in Perugia. And I think we made a lot of progress with what you're going to present to us. Thank you. Floor is yours.
Thank you, Otto, for your introduction, and thank you, everybody, and Lily in particular, to hosting me once again in this presentation after 1 year. And yes, as Otto remembered, this is the second time I speak in this community, but now I'm really part of this community, and it's a very good news and exciting news for myself and for my team. Oh, what happened? I went behind. Oh. Okay, sorry. So, first of all, who we are, because I'm not alone, of course, I'm part of a team. I came from the University of Rome Sapienza, and in particular from the Department of Earth Sciences, and we are a team of young guys. Today you will meet another cooperator of my team, Guglielmo Grechi, who is an early career researcher of EPOS, and we are working since 1 year with EPOS and for EPOS for integrating our activity inside this community. But our experience before EPOS, which is, we are expert in landslides, and more specifically in ground instabilities related to landslides and involving the effects on the ground due to the climate, due to the meteorological factors, due to the stressors of the environment. And we already are managing 3 natural field laboratories in Italy that were funded by several projects, both from national and international, so European funds. The first one is the Poggiobaldi Natural Field Laboratory in a mountain area of the Central Apennine. The second one is the Acuto Field Laboratory. It is a quarry abandoned in the hill area, not so far from Rome. And the third and the last one we produced actually is the Ventotene Field Laboratory in a highland, very stressed by the winds, but also by the sea. And what's the concept of these natural field laboratories? We study nature in nature. So we want to study the natural processes affecting the ground instabilities in the site, in the location where they really occurred. And the idea of our natural several laboratories is very strictly related to the concept of downscaling and upscaling of the laboratories. So the last year I was very felt by the existence of a community which is a multi-scale laboratory in EPOS, because I find this concept very, very useful for our idea of laboratory. And the 3 laboratories we are managing are now part of a more organized system. Yes, because since the August of the last year, we are part of a unique infrastructures managed by Sapienza. It is the Rome Technopool structure, and we are part of the testing land laboratory. So the testing land is a unique system, is a unique laboratory, integrating 3 different parts of experimental sites. But why this? Because we are now ready to provide services also in terms of instruments, sensors, experiments, or a controlled experiment in the sites. And this is an example of the very last laboratory we produced. You can see a multi-parametric and multi-sensor installation both in the ground and below the sea level. We manage this installation not for monitoring and giving early warning. This is really an experimental site. So we perform experiments here, not monitoring. This is relevant to understand the meaning of this providing in these potential services. But which is the data we have, which is the data we want to give to this community and share with the international community through EPOS. We collect continuously data from potential actions, causative factors. So sea waves, wind, rainfalls, earthquakes, all the environment can produce against the ground instabilities. And we record the effects of the ground to these stressors. These occur simultaneously. So we have every minute data continuously from the causative factors and from the effects. This is the core of our data set. And so what we can manage with this data is to analyze by statistical approach, by observational approach, by cross-correlation approach, what occurs in the environment and what is produced in the grounds. Or our experience in EPOS until now, 1 year of experience, more or less, because I spoke in this community just the same week of the last year. It was a very intensive experience, really, because, yes, the last year we was very new, me and Guglielmo, and it was the first time we met all of you. It was a great pleasure, but immediately during the first session of the first day, we had a touch, we had a contact with the multi-scale laboratories community, because we found the topic of the community very close to us. So we started immediately a community hosting, and from March 2025 to November 2025, we go on our community hosting, and we insert all the laboratory in the platform managed by the Utrecht University in the field of in the context of the multi-scale laboratory, and we participated in November to the annual meeting in Montpellier. We were not yet formally inside the community, but nevertheless we would like to share our experience and to try to make experience with the rest of the community. And here we find, first of all, friends, secondary cooperators, and contributors. And so from this moment we had the idea to create a sub-community inside the MSL community that was named Field Scale Laboratories, where the geoenergy community already existing and the new community of ground instabilities decided to share the experience, to create a new domain, and to find similar goals. Yes, because both of us had continuous data as a sequence of series of data that can be distributed and and analyzed by the possible users. And then from November to March, we are working on our work plan, our scenarios, our goals to be achieved in the next year. Starting from the work plan, now the sub-community has 3 main work plan goals, and we are working on that. So we are really concentrated in merging our experience, sensors, time series, how the data can be potentially downloaded, uploaded, managed by a service that not yet exists in the EPOS system. And this is an idea of scenario of potential users. The questions, how can I use multiple data from multiple sensors in the same site for analyzing them, for example, by machine learning or statistical approaches. So context selection, data downloading. All these steps has to be discussed in creating a new service. And the goal is just to expose, to produce this service in EPOS platform through the multi-scale laboratory community. And well, the 2 goals we'd like to achieve in the short and in the longer time are, the first one, the exposition of the data, because we have the data. Now we need the service, the ET service to show the data, but to make the data downloadable according to the meaning of the data themselves. So we need that the downloading can be performed using the window, a time windows in which all the different time series for the different sensor can be downloaded, because it's the simultaneous data that is relevant for analyzing the effects we are researching on, and the community, the international community dealing with this topic is researching on. In the future, as a second goal, we want to expose services of data analysis. So, for example, machine learning algorithm that can be already trained in the site, and so produce a service for also data interpretation and analysis. This is a longer time goal, but we have in our mind this possibility. So for the moment, that's all. And so I thank you for the attention. Thank you, Otto, once again, and Lily, for giving us and my team the possibility to be here at less than 1 year to be part, actually, of this community. Thanks to all of you so much.
Sorry, I have. Okay, so thank you, Salvatore. And also important to say that Salvatore very optimistically said this is an activity that it actually ran over 1 year, but we started discussing about the data in Corfu. I don't remember exactly when. The year before. And so the approach was really from Salvatore to EPOS to say, we have as a community this data. We really would like to share this data and to integrate this data in the EPOS platform. Can we then discuss together how to do it? And then last year here I invited Salvatore to present the data with the hope of triggering something from the community. And indeed, I was right, and we succeeded, because immediately there was this connection between the activities that the Salvatore team is doing and the TCS multi-scale laboratories. And I want to thank the multi-scale laboratories for being so open and so inclusive, to have such an inclusive approach to welcome a new community into the TCS. And so again, if you have any desire of integrating different data, different communities in your TCS or in EPOS, please put it on the table, because we can do it. Thank you again, Salvatore. And thank you to the multi-scale laboratories, TCS.
Okay, so next presentation will be focused on development of European quantum infrastructure project for gravimetry, presented by Sébastien Merlet. Please, Sébastien, the floor is yours.
Thank you. I also came last year to present this project that we hope it to be funded, and this year it is funded. So we started in last June, so close to 1 year ago. And immediately after, we were able to propose and to make a measurement. Is this a pointer? No. And to make a measurement in Greenland, you can see at the bottom here a gravimeter at Greenland. And we managed to make it operate outside the laboratory, which was an evidence of the time that arrived to deploy this kind of sensor in the field. And okay. Yes. No. Thanks. And we are sure quantum gravimeter will play a key role in the future for the monitoring of Earth and tackle our most pressing societal challenges. And in this project, our mission is to establish a long-lasting entity, perennial research infrastructure managing a shared park of instruments and also a perennial network of quantum gravimeter over Europe. So the project starts and it counts 20 partners of 11 countries for 4 years, and it stands on 4 big pillars. So the first one is to acquire and test quantum gravimeter as fast as possible in such a way we can deploy them on the field in identified use cases, in innovative protocols, to acquire data and to collect them, to store and share them to the wider community as possible. And the last pillar, very important, is community building in such a way we can propose, in such a way we work to propose a long-lasting entity. So here you can see the partners and where we will install a sensor all over Europe. So we will have permanent measurements in networks in some places and repeated measurements in some other use cases, and also onboarded sensor to make some mapping. Data will be dealt in a few places, and also these activities will be traceable to international unit through comparison. This project is the first step in the European vision, a Quantum Europe strategy to 2030 and beyond. And we are the ground segments of this vision in such a way in Europe there will be networks of quantum gravimeter measuring continuously with satellite missions, which is already ongoing through Carioca PMP projects. And maybe in between, stratospheric balloon will be a project will be also started. So our consortium is helped, and we ask help for an external expert advisory board, in which composed of 6 people, and you can see Martin Lindberg. I didn't see if Martin is there today. Is also in this expert advisory board. So the first pillar on instruments is to acquire sensors. So we will have 10 sensors acquired in the project, plus the one we already have, and we will test them in a metrological laboratory. So here you can see a gravimeter, and here a gravigradiometer. And the last sensor we will have to develop, this time we will develop it, is an airborne quantum gravimeter that we will test in plane and also balloon. So in this kind of laboratory, we will train people in such a way they are able to deal and to make measurements with quantum sensors as soon as possible to deploy them in the field. So in the field, we already planned 8 use cases to show the capabilities of the sensors. So it ranges from water monitoring to geothermal energy with measurements on volcano and also climate change, several applications to show the evidence of the capabilities of the sensors. So here, don't be afraid, it's just to show how we plan all the use cases. In such a way, I can show you the first sensor we received is this black triangle. And this black triangle, in such a way, we will make an exercise of sharing it, this sensor. It goes from one use case to another use case, to a comparison, then another use case, and then will be available for the external community of the projects, laboratories or team not involved in the consortium. In such a way, they can request this sensor for their own measurements and participate to new use cases. Of course, all the data will have to be accessible, and they will be stored and provided following the FAIR principles. And with that, we have in the EKIPG projects many actors of the EPOS ERIC and also other actors from EPOS to participate and to propose with us the integration of this data, and also to propose future thematic core service for gravimetry. So here you see the planning of these activities on data in which participate a lot of institutes. So I will not enter in details of deliverables and milestones, just say that up to now, we already have the repository on which we put the data of the sensor who already started to make some measurements. The methodology is validated. We make the gap analysis inside the consortium, and it has been then it reached to a fair aware seminar. The first one has been done a month ago, and new ones will be organized next month. So this is ongoing, and the goal at the end is to have collected and to store all the data to provide them and to share for the wider community, scientific community. With this data and also the preparation of a thematical service, this will help for the community building that we are preparing with the goal of democratize quantum gravimeter use. And so we are building a wide community in such a way we can propose at the end of the project recommendation for the future entity for long-lasting activity for quantum gravimetry. So we propose 2 wide workshops. We propose 2 open call to borrow the sensors. Of course, people that will have this sensor will be trained. This will allow us to identify new use case and work towards new thematic core service. So the next steps. Here I put next steps, but I also put the beginning of the project. So the beginning started in June with the kickoff. As you have seen, first use case can be started in Greenland. We were able to demonstrate a long measurements of more than 3 months continuously with this kind of sensor in a laboratory before be deployed in a use case for monitoring of hydrology. And we receive at the beginning of the year, so during all this period, we make most of the tenders to acquire the sensors, and we receive the first sensor at the beginning of this year, and it is already measuring after a phase of test of 15 days. It's now involved in a use case on the field. We also perform the first training session inside the consortium actors. In April, we are preparing, because next month we have a 2 weeks comparison of the sensor we already have before being deployed again. And most important, the first workshop will be held in the beginning of June. So you're welcome to help us and to participate, to advise, and to be involved in the establishment of this large community, and if possible, to the establishment of the thematic core service. And we will have the first open call for sharing in such a way people can request for sensors for the summer this year. So the goal, after the end of the project, at the end of the project, is after a second workshop to propose the roadmap for the establishment of long-lasting entity. So registration are open for our workshop. It will be held at Potsdam from the 3 to the 5th of June at GFZ. So you can ask Marvin Reich, who was there last year, some details. If needed, you can also ask us. I will give you the name after, but we are at least 3 from the board of the EKG project here today, and you can use this QR code to register and to have access to the website. So today, I am Sébastien Merlet. Jean Lautier is also here at the end of the room. So please, Jean, rise in. If you need, Jean is the chief of the project to help me. Each work package has a leader. So Marvin Reich from GFZ for the community building, and Lucia Sewan, who presented 2 years ago when we were in Rome at EPOS Days. Lucia is also there, and Lucia is the work package leader for the data activities. Also, we have other partners in the room who are in the projects, starting by Otto. So you can also come to Otto, and I thank you for your attention with these last words. Thank you.
Thank you, Sebastian, and congratulations for the approval of the project. Indeed, we discussed this last year, and we were still hoping that the project would have been funded, and it is. It is a great project, and of course, is a very important scientific project. But my understanding is also that the project is actually triggering the building of a community at European level that was not so ready to be all together. So the project will actually give the opportunity to work all together. And this is just for those who are not familiar with the EPOS, let's say, procedures or governance. This is also the way in which we establish new thematic core services in EPOS, and we hope we will arrive to this with this community. So we start with projects, of course, in which we put together the community. We do a lot of interesting scientific studies, and we put the basis for making a perennial infrastructure. And this is what we would like to do together with the gravimetry community. This is what we have done with the tsunami community in EPOS, that is now a fully established TCS since a while. And this is what we hope we will do with the build environment data, because again, this community started in EPOS within projects, and I'm very happy to announce that we just received an application for the candidate TCS status of the built environment data. Of course, now there will be an evaluation process. It's not that I can say how the evaluation will end up, but already having worked with this community for the past years, and being arrived to have this application for a candidate TCS is a great result. And I think this is possibly the path that we would like to follow with the gravimetry computer community. So again, congratulations for the project.
I think it's a great opportunity to accelerate things in such a way we can reach to this thematic core service.
Yeah, thank you.
Thank you, Sebastian. So we are moving to the next talk about myography as a new observational data type for the European Plate Observing System. Unfortunately, Jari Joutsenvaara could not come, and we don't allow to connect remotely. So we have a video presentation. So we will take time to see it now.
Ladies and gentlemen, I'm honored to present myography, a new observational data type for the European Plate Observing System. Although I cannot join you in person at EPOS Days, I hope this short presentation will give you an overview where the myography community currently stands in the process of integrating muon imaging into the EPOS infrastructure. My name is Jari Joutsenvaara. I'm a physicist and a development manager at the University of Oulu, Finland, and I'm also a co-founder of Muon Solutions Oy. Myography, it's a method that uses naturally occurring cosmic ray muons to image the internal density structure of large objects such as volcanoes, glaciers, and underground formations. The idea goes back to the discovery of the muon itself in 1936, and one of the first demonstrations came in 1955 when E.P. George used cosmic ray muons to measure the rock thickness above a tunnel. A famous experiment followed in the late 1960s when Luis Alvarez and his team installed detectors to the Cephren pyramid to search for the hidden chambers by measuring the muon flux through the pyramid. Although the experiment did not reveal new chambers, it did demonstrate that muons could be used as a probe for large structures. After that, however, the technique remained largely dormant for several decades. It took significant technological advances in particle detectors, electronics, and data analysis for muon radiography, myography, and the modern muon imaging to reappear as practical observation technique. Since then, the field has expanded rapidly into many areas. In volcanology, muon imaging has been used to study the internal structure of volcanoes, such as the Mount Etna in Italy, and in glaciology, experiments in Swiss Alps have used muons to estimate glacier thickness. More recently, studies have explored muon flux variations related to atmospheric phenomena, such as tropical typhoons. Muon-based technologies are also being investigated for positioning and timing applications. Today, the range of applications is even broader. Muon imaging is used in mineral exploration, in border security for scanning cargo containers, and in the infrastructure imaging of bridges, buildings, and dams. So what started as a particle physics experiment has actually evolved into a versatile observation tool across many scientific and applied fields. Behind these developments, there is now a growing international community working on muon imaging. Before introducing some of the organizations involved, it is useful to briefly clarify the terminology. The term myography was introduced around 2016 by Professor Hiroyuki Tanaka at the University of Tokyo, Japan, to describe imaging techniques that use cosmic ray muons to study the internal structure of natural and man-made objects. Today, however, the broader term muon imaging is often used across the field. Muon-based technologies also cover applications beyond imaging itself, including areas such as positioning and timing systems. Several research institutions have played a major role in developing the field. These included the University of Tokyo and Professor Tanaka there, who pioneered many early volcano myography experiments, the Vigno Research Center for Physics in Hungary, and also, to some extent, my home institution, the University of Oulu. The University of Oulu does have a long history in cosmic ray research and also in underground muon measurements, which eventually led to the establishment of a spin-off company called Muon Solutions Oy in 2016. In addition to academic groups, there are community initiatives such as the Virtual Myography Institute, which coordinates collaboration across the global myographic community. The field now also includes commercial actors. Companies such as Ideon Technologies, G-Scan, and our own Muon Solutions are developing industrial and applied uses for muon-based technologies. Today, muon imaging is supported by a growing network of research institutions, collaborative initiatives, and commercial applications. Before discussing how muon imaging could integrate into EPOS, let me briefly explain how the technique itself works. We can summarize the idea in 3 simple steps. First, high-energy cosmic rays constantly interact with atoms in the Earth's atmosphere. These interactions produce cascades of secondary particles, including muons. Second, muons are very penetrating particles. They can travel through hundreds or even kilometers of rock, ice, or other dense materials before being absorbed. Third, detectors placed below or beside a structure measure the angular distribution of the incoming muons. From these measurements, we can reconstruct density maps of large objects or phenomena. Regions with higher density absorb more muons, while regions with lower density allow more muons to pass through. There are a few important quantities involved in this process. One is the muon flux, which describes how many muons arrive per square meter per second. Another is the density distribution of the material we are imaging. Finally, the amount of material along the muon's path is often expressed using a unit called meters water equivalent, which allows different materials to be compared in terms of their effective thickness. Using these measurements and models, muon imaging allows us to infer the internal structure of natural or man-made objects. So briefly introducing the principle of muon imaging, the next question is how these techniques could connect to EPOS. As we know, the EPOS integrates a wide range of geoscientific observation, data services, and research infrastructures into a common framework. Muon imaging could contribute to this ecosystem by providing new types of observational data. In particular, muon measurements can produce density maps of geological structures in 2D, 3D, and also in 4D, which can in return help us to understand the internal structure of large objects such as volcanoes. This makes it possible to monitor volcano interiors and potentially observe changes inside volcanic systems over time. Muon imaging data can also complement existing geophysical datasets. For example, combining myography with seismic, INSAR, or gravity data can improve our understanding of subsurface systems. So the key idea here is a simple one. Muon imaging data can become a new observational layer within EPOS, contributing a new perspective to the existing geoscientific data landscape. So how does this integration actually begin in practice? At the moment, myography is at an early stage of entering the EPOS ecosystem. The current work focuses on building connections between the myography community and the EPOS research infrastructure. One of the groups involved in this effort is the Hungarian Wigner Research Center for Physics, which is actually actively exploring how muon imaging data could be integrated into EPOS services. Their existing volcanological data service could provide the first linkage. Natural entry point for this integration is the thematic core service for volcanology within the EPOS. And since muon imaging is already used to study volcano interiors, volcanology provides a logical first domain where myography datasets could be incorporated and tested. Another important aspect is community coordination. Initiatives such as Virtual Myography Institute, the Myographers community, and also the Finnish EPOS own community working on bringing the researchers together, working on the muon imaging and to help to coordinate the next steps of the integration locally and also globally. So the current phase is really about building the bridge, connecting the myography community with EPOS services, and preparing the technical groundwork for the future integration. One important point to emphasize is that the need for standardized metadata for myography has now been identified across several projects. In several Horizon Europe projects, they have highlighted this requirement when working with myon imaging data. In particular, EPOS On and MineIO have addressed questions related to interoperability, data formats, and the metadata structures for myography datasets. Myon imaging has also appeared in other Horizon initiatives, such as Agemera and Cryoscope, which explored applications ranging from mineral explorations to studies of permafrost, ice, and the environmental systems. Across all of these projects, the need for common metadata conventions has become clear. Establishing such standards will make it easier for myography datasets to be shared, compared, and eventually integrated with larger geoscientific data infrastructures, such as EPOS. The work toward defining these metadata approaches has been steered by several key actors in the myography community, including the University of Tokyo, the Virtual Myography Institute, the Hungarian Wigner Research Center for Physics, and also our partners in crime, the Myon Solutions Oy. Together with these efforts are helping to move myography from a collection of individual experiments toward a more standardized and interoperable data framework. So looking ahead, there are several next steps for bringing myon imaging closer to the EPOS ecosystem. First, it will be important to introduce the EPOS infrastructure more broadly to the myography community. Many researchers working with myon imaging come from particle physics or engineering backgrounds, so connecting them with the geoscience infrastructure community is an important step. Second, work on metadata interoperability and data formats will continue. Establishing common data conventions will make it easier for myography datasets to be used alongside other geophysical observations. Third, we want to strengthen the collaboration between geoscientists and myographers. Myon imaging works best when it complements other observation techniques, such as seismic measurements, gravity surveys, INSAR, electromagnetic, etc., etc. And a practical step in this direction will be to organize a dedicated myography session in Finland in autumn 26, bringing together researchers, infrastructure developers, and potential users of myon imaging data. Overall, the goal is to bring myon imaging into a broader Earth observation ecosystem and make it available as a new observational data layer within the EPOS. With these words, I would like to conclude my presentation. So myography is a new method, still emerging from its particle physics nest, but it has already shown promising results also through different disciplines, different appliances, and thus it does have a really good possibilities to benefit also the geoscientific community. And do not hesitate to contact us. Our contact details are on the slide. So myself, Jari, or Marco, and we will be happy to assist you further. Thank you for this opportunity.
Thank you, Jari, although I'm not sure whether you're out there somewhere with the muons in the atmosphere. Bit strange. Again, a pleasure for me to introduce the last speaker of today, who again will talk about a subdomain in the multi-scale laboratories, but this time about the global dimension in the geochemistry domain. Marta, the floor is yours.
Hello, thank you. I was invited here today to speak about geochemistry, and actually it's still up for discussion whether it's a subdomain of multi-scale laboratories or could be something broader. So this is part of the reason why I'm here today. We're not yet, or I am not yet involved with EPOS formally, but I think there are many options that I would like to explore with all of you today and in this week. So I'm here today speaking on behalf of One Geochemistry. One Geochemistry is an international, it's a global initiative collaboration between different geochemical data providers with the goal to standardize on an international level, so establishing a sort of a global international standard or multiple standards for geochemical data. There were two things I wanted to point out on the slide. One, EPOS MSL is already a member of One Geochemistry, so actually we are already partly connected. And One Geochemistry is also, it's endorsed by 6 of the major geochemical scientific societies and unions, which on the international level obviously gives the initiative a certain level of authority. It also means at the moment we are, even though we're talking about geochemical data generally globally across all sectors, we do have a bit of a focus on the academic sector. So we have some governmental partners as well, but it's mainly, I'm going to speak about academic data, just as a caveat and to set the scene. So I've already said that the reason why I'm here today is to talk to you of how we can integrate more geochemistry into EPOS. And I'm obviously well aware, and we've heard in the last 2 days already that there is lots of geochemistry in EPOS already. But I think there is more to be integrated. So that's what I want to talk to you about. But before we talk about that, I wanted to give an introduction of the different types of, like, what types of data are we actually talking about, and what are these standards that already exist and that we are continuing to develop. So geochemistry as a discipline is very typically a long tail discipline. So you can see on the top right here is the sort of the original definition of what geochemistry is as a discipline. And you can see from this definition, it's incredibly broad, which means, so in this definition, that's already got in it many, many different subdisciplines to specific data types and sample types. So the individual geochemical data sets are usually, they're highly specific and usually also small in size, which can be good, but is then also a huge challenge for standardization, of course. But standardization is important partly because, as you can see here, in the last 20 years or so, we've seen this massive increase in the volume of data available and sort of published by the research community. So these are data from the GeoRock database. So this represents one subdiscipline within geochemistry. This is igneous geochemistry, but it does scale and represent the discipline geochemistry as a whole. So looking at the geochemical data pipeline, just sort of background of what are we talking about. Traditionally, usually what we're talking about, we have a sample or multiple samples. We take those to a lab, analyze it with a method, and usually actually that is multiple methods, and it's often also multiple laboratories. That together then becomes a data set with hopefully a rich set of metadata as well, which will then get published as a research manuscript article. And usually, and sort of historically, this is where the story ends. But very quickly, it sort of became apparent that this is great on the sort of local level if you want a local study to characterize the geochemical makeup of a specific setting. But if we want to think sort of more globally, more big picture, we actually need to combine multiple of these data sets and aggregate that information, harmonize the data and the metadata in synthesis databases to then really be able to enable new and sort of bigger picture scientific insights. So actually geochemistry is a very special discipline. Or at least I think it is fairly unique in that very early on in the data history of that discipline, it already started with the synthesis databases. So from the very beginning, well, not the very beginning, but so for 30 years now, 25 plus years, we have had a number of large synthesis databases, and I'm just going to walk you through one example, which is the GeoRock database. But basically, these databases, their mission was to collect and aggregate and harmonize all of these individual data publications from the academic literature, bring it all into one place, collecting both the actual chemical data, but also a rich set of metadata that describes the publications, the samples that those data were measured on, and the analytical methods. And then because you can bring all of that together, and if you can harmonize it, that then enables a very customizable search options, basically. So you can select any number of different filters to sub-select the data set and data compilation that is relevant for your research question specifically. So this is something that in geochemistry has existed for quite a long time. So there are quite well-established standards for certain sub-disciplines within geochemistry out there already. So the GeoRock database is one example, and actually this is partnered with an affiliated or sister database called EarthChem or PetDB, and together they cover igneous geochemistry. And what we're talking about here is sort of over the last 30 years, they've accumulated data from just under 30,000 academic papers. We're talking around 50 million individual data points. So even though each one of those points on this map is a very small volume of data in itself, there are a lot of them. So yeah, standardization is important, but it's incredibly powerful because that then enables sort of global scale studies, both in the geochemistry field or sort of traditional earth sciences, solid earth sciences, but also a bit beyond that, looking at, for example, geohealth. There's environmental aspects to solid earth compositions and vice versa. So coming back to this pipeline, so this has been happening for the last 25 years, basically. We've got the workflow I've already described ending in a manuscript publication that then gets harvested into a database. The problem is that relies on authors to describe their data well, document every step, use compatible and consistent methods and method descriptions, and that all to be able to be harvested into the database. And that often doesn't work very well, and that's a huge vulnerability, weak point of these synthesis databases. So what the databases actually then realized very early on is to streamline this process. It would actually be really helpful if the authors, as well as publishing their research paper, would also publish a data publication which can then be harvested into the databases rather than having to go through the published paper. And the reason why that works and works well is because in this data publication, you can recommend and enforce data templates. So you can give them a structure for specific data types, subdisciplines within geochemistry, specific samples, for example, sample types. There are different formats. There are recommendations out there. This is how you should report the data, this particular type of data from this particular type of sample. So the examples I've put up here are 4 examples developed by the EarthChem system, so the EarthChem database, which also run a data repository called the EarthChem library. And these are templates that were developed by the database, but in communication with the community, with their communities. And they're actually templates that are now also implemented by GFZ data services. So these are things that we can transfer to other repositories, making sure that we can actually globally harmonize and interoperate. So just to summarize all of this again graphically, basically the situation we had for a very long time, and this in itself is unique, that we had these synthesis databases already that harmonized data from multiple different publications, but they were taking it all from papers, from PDF publications or papers. So that was massively improved, that process, and the quality of the data harvested through this integration of the repository, the domain repository. So this is where either in collaboration or the actual database systems developed their own repositories, and they developed these and implemented these templates that helps the data flow into the databases. And then there's actually a third aspect to this, which I just want to very briefly mention, is that in this particular example, the EarthChem PetDB database and GeoRock are also then further harmonized through the EarthChem portal on the right, which is basically a database of databases. So that's aggregating two separate databases again to give even better access to data to the users, to the community. So with that, let's briefly talk a little bit more about the actual standard development going on. So I've already talked about the templates. That's obviously a huge and important part of it, but it does go beyond that, and that brings me back to 1GA chemistry and why I'm here today. So one of the central goals for 1GA chemistry is standard development for geochemical data. But 1GA chemistry is doing that not just from the perspective of the data systems, so the databases and repositories, but it's also talking to the researchers, to the community. It's talking to the geochemical societies, to publishers, to industry, etc. So the idea is really to try and create something that works globally and for everyone, which in the end, because the field is so diverse, it's not going to be one standard. It's going to be a set of different standards for different types of data. But if we can do this well, they can then interoperate well and can be mapped to each other. So one of the first things 1GA chemistry did and is actively still doing is just compiling all of these different best practice recommendations that are already out there. So basically the templates, the sort of the information, domain information for specific subdisciplines in geochemistry. This is just some examples from the 1GA chemistry website. There's a long list of papers, mostly resources that describe for a particular type of geochemical data, this is how you should describe it and how you should report the data. So that's step one, and that's sort of the content of what you should be publishing when you publish your data. The second aspect of this is the language, so vocabularies. So 1GA chemistry is currently very actively encouraging all of its member data systems to formally register their vocabularies in RDF format. So this is one example for analytical methods, which is a collaboration between multiple of the data systems within 1GA chemistry, published through Research Vocabularies Australia. And as you can sort of see from this example here, this is a very sort of highly structured hierarchical vocabulary. It's both human and machine readable, which then enables linked data in the future. And one of the really exciting aspects of SCOS in particular, where's the pointer? On the right here, you see these alternate labels, and that basically allows us to preserve all of these other versions of names of this particular method that have been used by researchers in the literature. So the terms that people wrote into their papers can still be linked to the one sort of recommended term that is used in this vocabulary, but this old information, the legacy information, doesn't get lost. And this is just one vocabulary out of many. So this is the example just for the GeoRock database, the different vocabularies that are used within this database. So the methods is the blue box on the far right. That's one of them. There are many, many others, and the details don't matter in this at all. I just want to show you the volume and the number of different vocabularies that are being used. Some of them are already registered. Others are in the process of being documented and registered in the same way. And sort of taking this back to the templates as well, this is obviously, they were first developed, I think the earliest one are probably 5, almost 10 years ago now, but they are also being continuously updated, and obviously these vocabularies would go into the templates, and the best practice documents would also inform what the template structure should look like. Now, another thing that 1GA chemistry does, and I've already sort of mentioned that we're talking to journals and journal editors. So one of the initiatives is something called an editors roundtable, which is basically, it's a conversation between the publishers, the editors, the journals, and the data system, specifically the data repositories, talking about how do we improve the publication of geochemical data, what are the requirements that we should ask of authors at manuscript publication step. So this is something that was first started in 2007, so 20 years ago now, and they released this first policy statement that I've just shown you the screenshot on the right. But it's an annual meeting that happens at the Goldschmidt conference, which is the big annual geochemistry conference. So this is an ongoing effort. And one of the really exciting things that's come out of this recently is work with the new Diamond Open Access journal called Advances in Geochemistry and Cosmochemistry, or AGC. And they basically, as they were setting up this journal, they attended one of these editors' roundtables, and then, as a consequence, worked with One Geochemistry to develop their data policy. And they've got now one of the strictest data policies out there for a geochemical journal, and they are really enforcing this throughout the publication process and making sure that their authors comply by this policy and publishing good quality, complete data sets. So the final thing I wanted to mention on the standards topic is that because of all of this work that One Geochemistry has been doing over the last few years, they were then actually invited to be part of the World Fair project, which is looking at cross-domain fair policies and interoperability in particular. So One Geochemistry, or geochemistry, was one of 11 disciplinary case studies. It's one of the I don't know if you can read that, but one of the red petals on that diagram grouped together with nanomaterials and chemistry. And obviously there's a lot of chemistry and geochemistry, so there is a lot of overlap. And that really allowed us to communicate with these other disciplines and find common ground as well. Okay, so with that, I think what I wanted to bring across is that geochemical data is diverse and complex, and it's not a one solution fits all. But at least through One Geochemistry, we actually have many connections on the international level, and there are efforts out there for standardization. There's lots of standards, individual standards that already exist, and there are active efforts to bring all of this together under one hood. So how can we connect this more with EPOS? And this is basically just the final few points as a discussion starter, either for now in the discussion, but also through the rest of the week. And basically, I see 3 avenues of integration that we can pursue. And one of them is very much at the data set level of just exposing more geochemical data through EPOS. And this is, I think, very much where the MSL connection is the obvious route, especially because the GeoRock database example I've been talking about, they're partnered with GFZ Data Services as their domain-specific data repository. So really all we would need to do here, this GeoRock database, DGIS repository, is already one of the data centers in GFZ Data Services. So all we need to do is add one more data center to the existing connection to the EPOS MSL portal and harvest those data sets as well. So that's something we could do this afternoon if we wanted to, in theory. And as far as I understand, I think this option, this avenue, would also be relatively straightforward to extend to other repositories in the geochemistry domain out there. So, for example, the EarthChem library, which hosts a lot more geochemical data sets than GFZ Data Services does at the moment. Avenue number 2 is related to the databases, and so the synthesis data that is already aggregating all of these different data sets published elsewhere. And this is a different beast, but actually it's quite similar to what we heard about Eurogeographics earlier. So I'm very grateful to that presentation. So just the reminder of the sort of this is, I think, for these types of data, the map-based visual on geographic entry point is probably most appropriate. So something probably more through the central EPOS portal. Ideally in a way where enough metadata is harvested that you can do a sort of pre-filter, pre-selection before you then get redirected to the actual specific database that hosts the data that you're interested in. So this is something that we started to explore with Rosanna and Katie, and it's sort of with GeoRock, the API doesn't quite match the requirements yet, but that's also something that is straightforward to set up if we wanted to do that. The third avenue is related to the standards, and this is a sort of going the other way a little bit. So I think this is very much a sort of give and take situation where EPOS can contribute to 1G chemistry and 1G chemistry can contribute to EPOS. And this is on that particular aspect, actually, EPOS MSL is already a member of 1G chemistry. So in a way, there is already an exchange of ideas and around the standards happening already. But as you all know, and as I am continuously learning, there is lots of additional geochemistry data in EPOS that isn't just in EPOS MSL, just in multi-scale laboratories. So this is where I would like to talk to you over the next few days. What else is there? What do you have already that we should also know about? What can you help 1G chemistry with, but also which of the standards that we've collated and developed would actually help you with your services? And that's basically what I wanted to say. So I'm going to leave you with these 4 sort of discussion starters, discussion points, and I look forward to speaking more about this. Thank you.
Thank you, Mate. So I believe we are in a very good time, is it?
Yeah.
Half an hour? Yeah, half an hour for question, answer, and discussion. So any questions already? I have several, but I would give floor first to all of you. If you have any questions to the presentations we just heard, please just raise your hand and the mic will arrive. Please wait for the mic before starting posing the question. I don't see any hands raised yet. Okay, Michela, please.
Thank you, Jan. I have a question for Salvatore that presented the instability domain. Just a curiosity. Now the community is Sapienza or include also other partners?
No, the sub-community in the multi-scale laboratory is not only Sapienza, because there are the partner of the GeoEnergy and also other partners from the TH of Zurich, Liliana, and other colleagues. So the sub-community is not only Sapienza. Sapienza have the 3 laboratories that I showed before, specifically on the ground instabilities. The other partner of the sub-community have natural field laboratories not focused on ground instabilities, but anyway, all these laboratories have the same concept idea, which is the recording continuously of different by different sensors of different kind of data. And so our necessity is to create a service for giving the possibility to select time windows in which you can download several time series of different sensors to be analyzed in this form. But the topic of the different natural field laboratories is not the same in the sub-community of the MSL.
Thank you.
You're welcome.
Thank you, Salvatore. I have actually also a question to you or to the field scale laboratories, because you mentioned those 3 locations in Italy, right? Actually, the question is actually to all of you. If there are other similar observatories around Europe with possible similar or different instrumentation, is there any collaboration already ongoing, especially regarding standardization of the data and metadata?
Okay, as it regards the ground instabilities, yes, there are. I think they are not yet in the EPOS community, but one of the goals that we have for the future is to, as soon as we will have the service exposed, we can easily contact this community to see if they are interested to cooperate in EPOS with a similar approach. And so this is, in my opinion, a goal that we can achieve for the medium long time respect to the first goal we have, that is to create a new service more specifically adapt for this kind of data. Because in this way, the community that can recognize themselves in this kind of data can be much more attracted and so interested also in cooperating. This is my idea, of course. I'm not sure of this, but okay, we can try to move in this direction.
Thank you. I have actually a suggestion, because to use the network we already have within the EPOS family to also get in touch as soon as possible also with Salvatore and these labs, especially for the ground instability, to align the standards, the needs, because so it should be broad enough to accommodate all the potential new data. So if we start developing or they start developing the service, it can also accommodate the needs from other fields or other instrumentation. Any other question? Daniela? Sorry, I'm not sure who was first. Ronald, yeah, please.
Right, so it is now focused on the landslide aspect of it. But ultimately, these are field scale sites to better understand the properties and processes controlling the Earth behavior. Right, so in that sense, there are more sites. They're actually very similar in that regard. So large sites collecting site-specific multidisciplinary data. There are the geoenergy testbeds, there are the landslide facilities. But I also wonder if there's a natural fit with the near-fault observatories in that sense. So we can see if we can expand the scope a little and make a harmonizing step in EPOS. Does that answer your question as well?
Well, for the near-fault observatories, I guess those are at a much larger scale than the field labs regarding the ground instabilities. Of course, they are related because the earthquakes can generate a big landslides there as well. Yeah, but I'm not sure whether there's direct interconnection between those.
It's an open question. So I'm not saying there is a connection. It's an open question to explore whether there is one. When you say at a larger scale, do you mean at a larger spatial scale, or do you mean the community is larger?
No, first I meant the spatial scale, of course. Okay. Yeah.
So site-specific multidisciplinary data collection with the goal of sharing time series data. I'm just asking the question, is that sufficient ground to explore harmonization on further? Question.
Well, I guess the question is to plenary, right? Especially maybe to people from the NFO, if anyone has comment on that.
But can I, because my understanding of your question, Jan, is kind of, because we are making these efforts or working on services to integrate and expose the data that are now within the TCS multi-scale laboratories. Let's do that, having in mind that there might be other labs that would like to integrate this kind of data. So let's not do this, which is a lot of work, thinking only at this kind of lab and the data that you are producing, but let's do it at a larger scale, mainly spatial at the moment, because these are field laboratories, so it means they are spatially located in other place. Then I see your point. Let's see if this kind of data can be actually integrated in other communities. These data, like others that we just discussed today, because I mean, I have the same question for other presentation that just were other topics that were just presented. But I think that the young point from the perspective of working on the service is let's do it having in mind that there might be other labs. and that are producing the same kind of data, and that might be, once we have a way to integrate this data, they might be interested. But let's work with them since the very beginning. Let's at least explore who they are, which kind of data they are producing, and let's explore since the very beginning if they might be interested.
Yes, Lily, sure. And there is an interesting, good point for starting in this inclusion approach, as you suggest correctly, that all the already existing field laboratories of the subcommunity are, how can I say, agree on specific requests that we need, not for the type of the data we are collecting, so which kind of sensors or which kind of parameter, but for the logic of acquisition of the data. So a simultaneous, continuous, with a huge quantity of data that continuously enter in the data logger systems and in the server where they are stored. So this is the starting point, and this is something that is already common in my mind to other communities that are not inside. So I mean, we are already okay. We have clear in our mind that it's not the type of the data we insert, but is the different way in which the data is produced and requested by the communities that use this kind of data. Continuity, synoptical data, and the possibility to upload and download with windows, with time windows of simultaneous recording. These are a specific request for this service in our mind.
Yes, I will just comment. Indeed, we have similar type of services in place already, so it'll be good to learn from what we have in place already and how to fit yours. I'm not sure actually who was next, but there was another question there.
Yeah, but can we reply on this?
Okay, Lauro. Oh, so yeah.
Yeah, no, the last comment just confused me a little bit because this is exactly what we do in the near fault observatories. I think the difference is more thematic. If you study gravitational movements or phenomenon like that, you're not study faults. Otherwise, we do exactly the same. We continuously monitor with different instrument, the same object. In our case, is a fault. And now I just wanted to to make a comment on one geochemistry, and just to say that our community near fault observatories in different sites in Europe continuously collect geochemical data and like CO2 degassing systems or water systems, and so of course we are very interested to understand more about that. And of course, we have metadata because in order to distribute the data, this is mandatory within the EPOS framework. So this is just raising the hands that we can talk with time later on.
Yes, thanks. Exactly, that's the point of this meeting. Exchange ideas and discuss the way forward. So yeah, please take the opportunity of this week to discuss whatever clarification needed.
Sorry, can I make a comment on the previous question? Of course, the way of thinking, indeed, coming from ground instability in terms of multidisciplinarity and time series, is in the same direction of near fault observatories, partially also in the same line of volcano observations. And I think indeed that we should profit using a cross-disciplinary approach to try to find common path for data sharing, visualization tool, which are already in place, and we can support in this frame of cross-disciplinary interaction, eventually thinking a potential sponsor research activities in this line to support the inclusion of data. I will say, on the other hand, that culturally, near fault observatory community is looking to specific object, and the mission is to understand the earthquake processes independently of the scale. Could be really on-field scale, metric sites or hundreds of meters or several kilometers is not really the scale of observation, but the mission and the goal are really different. That's why I think today that changing the scope and the mission of the TCS will not be feasible, while we can empower and enforce this cross TCS collaboration in order to help other actors to be at the same level or use already things that are in place and favor integration of data. And then, sorry, if I can continue on the line of geochemistry, indeed, there are two other initiatives already in place in EPOS. One is near fault observatories, still supported in EPOS Zone. You have shown quickly some results. And the same in volcano observation. Maybe Giuseppe wants also to add. And it seems with a slightly different philosophy, because we have their continuous time series with specific formats we have agreed and tried to be harmonized in the past within EPOS. And we should take the opportunity now to make those communities to talk each other, ensure that there will be continuity while making indeed new steps to integrate this new community and people wanting to enter into EPOS.
Yeah, Daniela. Sorry, Giuseppe was first. Do you have
Thanks. Thanks for this organizing this session, because it was an opportunity to touch different aspects of the possible cooperation of the current community existing in EPOS and the future initiative, the future communities. From the perspective of volcanological community, there was several aspects that was touched during this session. Very interesting. I started from the myography. Thanks, Jan. You organized a meeting last month with the myographic community and the volcanological community. During this meeting was clear that there are a field of cooperation. Probably Philippe is here in the room, and other colleagues from France. Given their interest in cooperating, in particular in the standardization of this data, these techniques is already used in volcanology. There are some limitations to apply these techniques in real research, but it's interesting for sure. So there is field for cooperation. Another aspect is consisting the gravimetry. So very, very good to see the launch of the new project. I'm only wondering whether at the end of the project you think your plan is to define the new community. So I'm wondering whether the community is related only to quantum gravimetry or in gravimetry in general. That's probably I missed this point, but I think it's important. And the last point is concerning the one geochemistry. As anticipated by Gaetano, our community is of course interested. Volcanology produces a lot of geochemical data in broad sense. And already in our TCS, we started to harmonize the standard, the metadata, etc. There are some papers already published about that. Probably later with Marta, we have the opportunity to talk about this. And I'm very glad to know that there is to confirm that there is a field for cooperation. I hope that we can also share our standards. The standards developed by our community probably are the same or different. I don't know. I'm not expert, but I think that there is a field for cooperation also in this case. And I'm very happy to use this opportunity of the EPOS Days meeting to continue this cooperation. Thanks.
Thank you. I will just comment on the myography because that was indeed bottom-up activity because the myography was active. They are, of course, in the EPOS own project. They raised this request. We need to figure out who is interested from the existing thematic communities in EPOS, how to use the myography for their own sake. And also thanks to the communication office, the EPOS, we arranged this short first meeting across several TCSs with myography. So, but again, the actual activity, the initiation came from the myography. I think the second question was related to the gravimetry data. Sebastian, do you want to reply? Actually, I had the same question, how it's aligned with other gravitational measurements and alignment with the existing project.
Yeah, it already exists several communities with data on gravimetry for spring measurements, superconducting measurements, also absolute database. They are separated. And we think it's a very good idea, a very good opportunity to start with a small community for quantum gravimeter because there is not so much. And we will then ask the other to come with us for a wider thematic core service, more or less. At the end of the projects, we hope we could, it's a bit long to obtain the status, but we could be close to have this thematic core service, I guess, for quantum data. And we also think in integrating the other data such continuous superconducting data, absolute points, localized, and so on, because we will make both. We will make continuous gravity data and also localized absolute gravity data, which can merge the two communities of continuous measurements with relative superconducting gravimeter and absolute FG5 or other free fall corner cube gravimeter.
Potentially, there is opportunity to
Yes.
include a very wide community with different, also scientific aspect, as you mentioned, absolute, continuous, superconductor. So different aspect, different techniques. So potentially there is also a scientific objective, very appealing, also probably also very challenging because, as you mentioned, there are the community is different for many aspects. But
as explained
I
by,
encourage you to try to.
The goal is that, as presented by my colleague Lucia 3 years ago when we were in Rome, she explained that there is already a database for absolute gravity measurement. And the another IGETS database, which is for continuous monitoring. It's more or less the same people in different database organization. And I think the project is a good opportunity to discuss with all. Finally, it's not so much people. Let's say 40, 50 people. And if we all agree together, it will be, and thanks to the project based on 10 or 15 sensors, it can push users.
Thank you. The next question, I believe, was Daniela. Sorry.
Good.
I think Daniela was first, so.
Yeah, thank you. So yeah, that's a question for the geochemical community. So basically for Marth. In her presentation, so in your presentation, Marth, I don't know where you are. There, okay, great. So thank you, very nice indeed. And at some point you presented this database of publication to which data is connected. Let's say that in EPOS is a data-centric infrastructure. So, and it's not by chance that all the keywords, even in the papers, research infrastructure, data, services, stuff like that. And so I think it's very important to remark since the beginning that the key concept is the data set. And so my question was, it's maybe something I didn't catch from your presentation, whether you would like to have this mutual integration between EPOS and One Geochemistry on the data, basically, so integrating the data, okay. And yeah, so the system needs an evolution. Is it like that? Did I catch correctly from your slides?
So I think there are multiple ways how we could connect. Yes, it should be data-centric, absolutely. But there are aspects that go beyond just a data set published in a repository where I think we can collaborate, and that is something we can discuss and evolve on. But there are systems in place already where things like that, workflows like that exist.
Thank you.
Thank you. Sorry. Yep.
Hi, this is Carlos Garrido. I'm in part of MSL Multiscale Laboratories. I have a comment on one geochemistry. In Multiscale Laboratory, we have the geochemical laboratory, which are the primary producer of geochemical data. Okay, so most of this laboratory, we produce data sets, and we are now seeing how we integrate this with a very different kind of laboratory, like experimental or whatever. So we were exploring actually how to connect, because geochemical data had their own vocabulary data set. So I was very pleased to see actually one geochemistry, because at least it provides, we had to really hard to harmonize geochemical among the different TCS independently, where geochemical data come from volcanoes or whatever, because there's already a big effort international actually in the way we try to curate the data, the database and everything, and getting vocabulary actually from EarthChem and similar, because they were already done. And our sample have a unique identifier and laboratory protocol. So we produce that data set, but our goal is how they are discoverable in some way. So it's really important really to talk to one geochemistry for the different TCS that produce geochemical data. I think one of the main concern is a geochemical laboratory, because we are all the European laboratory that produce this data with some kind of accuracy and thing that we had really to be sure that the data are correct, but also trying to harmonize to the international sphere of data set which are already there. So I think it will be really important just to talk in the different TCS that produce geochemical data, which I think there are two types. Let's say the monitoring in situ measurement, which are very different from the one produced by a geochemical laboratory, which is basically based on sample. I think one geochemistry more focused on sample produced in the central laboratory and geochemical data, and that data should really follow an international standard if we really want that all the EPOS data set, geochemical data, are really discoverable. That doesn't mean that the data set will belong to EPOS and will be in national repository, because most of us in our country, we are forced to do that in our repository, but we really need to open the discussion on who produce geochemical data, how we can harmonize. Instead, maybe we have a lot of effort, we are not talking together and producing different vocabularies in different TCS or so on. So I think this is a very important point. Maybe something similar in the future for geochronology, that we don't have really much geochronology in EPOS. That's my comments.
Okay, thank you for your comment. I was also happy to see the templates which are present. The second would be how to put them in practice, right? And depending on the instrumentation, the labs, and the tools which actually are taking into account these templates. But I really, Marta, want to comment on this back.
Yeah, thank you. Thank you very much for this comment. I think one thing I forgot to say or glossed over is that so my expertise is sample-based geochemical data, but One Geochemistry as an initiative is very much also interested in and thinking about time series data as well. So actually that connection to NFO is something I'm actually very keen to explore, because that's something that we don't have super well represented in One Geochemistry yet, but we know that it's also important. It's an important part of geochemical data. So yeah, thank you for raising that point again. Very much looking forward to talking to everybody.
Thank you. There was one more question back from Angelo. That will be the last question. and then, of course.
Thank you. Yeah, Angelo Strollo speaking for TCS Seismology. One comment that really, triggers again on the geochemistry presentation from Marta, and which has surprised me in terms of the global impact that community has and the activities that are going on there, and also from the comments now from the previous person about how much data there are within the community here, also in Europe and so on. Considering these 2 points, how much is this community ready to start eventually a journey towards a new TCS in seismology, rather than talking about connections and trying to find their home in the other TCSs?
A new TCS in EPOS, you mean?
Eventually, yeah, start to think about the dedicated TCS, because it looks like there is really a lot there. Yeah, so it's, and also there is an opportunity also of leveraging on a community within Europe with respect to the rest of the world, where there is a lot going on already.
Thank you, Angelo. I don't have direct reaction. I think I will give floor to Lily.
Yeah, and thank you, Angelo, because you really, you touched a point I wanted to touch as well. Okay, so starting from this last presentation, because then I would like to say something on all the presentations we had in this first session. So, Marte, the idea of establishing a geochemistry TCS in EPOS is since the very beginning, is underground since the very beginning. We never managed to actually aggregate enough actors around this idea. What you presented, and following what Angelo said and what the colleague also presented, it's really now more and more, I'm from that community, so that's why I think I can speak, because I know exactly what I'm talking about. So, what you presented, what Angelo just said, and the colleague said, it's really more and more convincing me that in EPOS, there is more than a space for having a geochemistry TCS. I think this is a great opportunity, finally, for EPOS to move in that direction, which is something, as I said, we were thinking about it since the very beginning. Also because it's clear that these data are already transversal to many other communities. So it's a kind of hard to see them fitting in one single TCS. So we need to discuss, and also another point is that there are communities in EPOS that are already integrating the data. They have services to make the data accessible and not through publications, but directly on the data. And so this is another discussion I think is important to do at the level of the communities, to see how in TCS volcano observations in near fault observatories, colleagues are working on making the data accessible directly on the data. As you said, one solution does not fit all, so this is not possibly maybe the final solution, but we should not, disregard this possibility, because the network of actors that there is in one geology, it's really what we need for a TCS. And so, enlarging what I want to say to all the other communities that we listen today. So I think we really touched many different sides of EPOS, because there is this geochemistry community that has the potentiality to become a TCS, but we are at and I'm looking at Jan, who is he worked a lot on ICS TCS interaction, and I'm also looking at the scientific officers to see if they actually share my vision. So we today moved from a community which has a huge potentiality to become a TCS, but we are still at the very, very beginning. We don't know exactly which is the perfect path to follow, but becoming a TCS might be maybe the best one. I mean, from the EPOS perspective. Then we listened about the demography data, and for demography data, my understanding is that, again, these are data that are cross-disciplinary, so transversal to different communities, and we would like to see, I mean, how to integrate this data, and in a specific community, start thinking in EPOS, and then I'm looking at Rossana about having a button that is transversal data, so not focusing on one specific scientific domain, but transversal to many different TCS. The quantum, the presentation from Sébastien. So this is the gravimetry community, which is has a huge potentiality to become an EPOS TCS, and is already started in a way this discussion within the project, and the comment from Giuseppe demonstrate that actually there is room for involving other maybe the same people, but with a different perspective. And so let's say, so again, one geology at the very, very beginning, we still don't know. The gravimetry community, that is a step forward, and so we are already discussing about having a TCS on that. Then we had the ground instability data, and we now, I mean, that at the moment are integrated in one TCS, and I mean, that was a process that we followed, and it seems I mean, very, very good, and probably the best one. And then we also learned about making visible through the EPOS platform data coming from a completely different community, Eurogeographics. They don't want to be integrated in EPOS. They don't want to become, I mean, a part of EPOS, but they want to collaborate with EPOS and share their data through the EPOS platform. So it was really, I think we covered almost all the situation. Am I missing some other opportunities for EPOS to collaborate with communities? Maybe not.
So one of the things that I was thinking about, obviously, is one of the underlying tenets of EPOS is open science. It's making data as available as possible. And when Marta was talking about the role of different actors in ensuring the availability of data, so that includes through the data publications, I think these are some of the example of One Geochemistry is something that EPOS can leverage in terms of the different examples of good practice to ensure that data is made available, and it is available in a way that the users need for their different applications. So I think this use case that Marta gave us today that brought in the other actors, such as the data journals, for example, which is quite a new and slightly, for some people, some experienced practitioners, is a bit of a new concept, but actually is a really powerful concept in terms of those who are creating the data sets, who want credit for creating the data sets, but are not going to go down that traditional publication route. So I think there's a number of opportunities there for EPOS to exploit the examples coming from One Geochemistry. We got two.
Okay. I'm done. Thank you.
Thank you, Lily and Helen, for the comments. So now we are into coffee break. Just one more announcement, suggestion. Please use these days, this week here in Cagliari, to get in touch with people you think you might need to talk to as soon as possible, because as you have the idea in your head, use the coffee breaks, the social dinner, whatever opportunity to start this discussion about possible collaboration. That's why we are here. So thank you for this session and enjoy your coffee break. We reconvene at 11:45.
I need to get there.
make it me introduce. I'm Vivian in Oxford, for Open Science Days, services at practice project to say because it's the only one in the VRI cluster that is dealing with templates, clients. So yeah, yesterday we have two posters, but I have I know I have shown them to Guy because together with Guy we are we know each other for years. Yeah, in Napoli. So I know that you are very busy today. Today, Thursday and the others, it's too easy to cover us the connection. I have seen from that presentation, but for we nothing in this one.
Yeah, knowledge is the outcome of the European promotion. What? We talk about the preparing and simple data. There is European so that's a there is the from nation talking about but yes, you correct. Because master DGU we go to explain like where also data, but this leader machine leader policy answer from anything because now the only possibility is the question is we have yesterday asked me for Scandinavia. Non è solo tagliati API and I don't know so well we can usually stuff more of the photos. So we can talk with Lorenzo outside of the
Allora io adesso
Ah, sì, sì, va bene, va bene. Un attimo che si intendono fare bla bla bla. Nel senso che l'Italia non deve l'avete fatto bene. Però quindi cosa hai fatto? Non solo adesso fatto il candidate, ma anche il contesto con prospettiva. Però siccome
Adesso è un 20%.
Ok, ce l'hai fatto per me. Questo per qua non c'è che sono un allora
Io così, guarda, possiamo fare Perché li hanno modificati l'altro giorno per cambiare il live. Troppo. Saliti col trapantello. In realtà sì, abbiamo un'altra cosa, però
non fare lui. Pensiero e azione. Io ho detto anche alla massa, prego. Oggi è il 16 marzo. No, è per dire la squadra.
Ricordi, sì, c'era un film.
In quella sede ci sono troppo prende e ci trasferisce e ricordi quanto cassetto vedi che sei quelli che sono tanto più infatti non te lo voglio andiamo a stabilire quello che è ospitale facciamo un attimo allora io non ho che c'è questo cambio assolutamente dove non piace tanto sono quest'altra passare quello che io ho detto quindi io lo trovavo la Francia su quell'altra però ti serve un numero diverso comunque mi serve diciamo quello che si fa
Vedo, apra
e questo non ti va partendo da quello Adesso l'abbiamo fatto, adesso noi dovremmo fare attività in cantiera sostenibile in questo pericolo che abbiamo spiegato, intanto che non arriviamo alle semplicemente quel siamo per arrivare. No, perché altrimenti voi rischiamo di già però a me sembra che però ci noi dopo la no, però allora ci prendo le carte oggi e domani. Vabbè, se no a città, andiamo a non è che vi cambiamo senza che facciamo le cose poi, tanto non è che lo cambiamo però non significa che dobbiamo costruire. Allora, secondo me, forse perché comunque tanto dov'è un po' una volta agli amici solo dovrebbero scrivere. Allora, noi assolutamente, ma secondo me mi ha dato questo e le tue generali poi se noi saremo cioè qui abbiamo fatto questa già cioè già questo santo di se diciamo non è un così credo che presente qua ci siamo vedete noi allora questo framework che sta facendo queste cose e una di queste cose è il coreano questa comunità di cui sei più recente e ce l'abbiamo noi adesso adesso tanto che ce l'abbiamo che abbiamo fatto con l'application adesso si tratta di siccome questa è un'attività i prossimi 3 anni però di sostenere i prossimi 3 anni penso che poi non so se però ma ci spaccato poi c'è vabbè, no, basta che Ma ti posso lasciare? Sì, c'è il presenta. No, è che non so che foto più sono serate.
Guardare, se no ci ho provato. Hai ricordato il film, siamo in inglese, Non ci sono parte, io ho detto, vediamo. Pranzo, andiamo insieme.
Can you please take your seat? Please. Everybody. Please take your seat. Thank you. So let's start. Not now, eh? Let's start the second session of the morning. If you take your seat, please. I can give the floor to Fabrizio and Antonio, the chairs of the session.
Thank you, Lily. Good morning, everybody. I'm here to introduce the second session about the EPOS on Work Package 3, and I will show rapidly some highlights about the achievements that we reached during the first period of the project. Okay. So Work Package 3 in EPOS On has a main goal to contribute to tackling societal challenges, and in order to define concrete actions that EPOS may provide as an added value for the society, and is composed by mainly 4 pillars. The first regard the enhancement and interoperability of the service or of some services concerning different natural hazards from seismic to tsunami, including also volcano part. A second pillar regard the interaction that these services can have with the operational stakeholders. A third one regard the definition of some ethical guidelines, and the fourth and final one regard the environmental impact of the EPOS research infrastructures. So I just show the first the preliminary results that we achieved during these first 18 months, starting from the subtask 3.1.1 that is led by University of Naples and in collaboration with other institutes that you can see in the monitor. And this subtask regard mainly the enhancement of existing early warning testing center, in particular Q and the near fault observatory infrastructures. And what they reached up to now is an extensive online-offline playback test with the tool Presto, and they are developing and testing other novel approaches. And what they achieved is an improved lead times and some promising reduction in terms of alert delays and decision modules. In the near future, they are going to experiment a multi-hazard approach for the disaster risk management, for example, including earthquake and tsunami together, but Antonio and Alexandro will show you better than me later on with a specific presentation of this aspect. The second subtask regards mainly the tsunami, and in particular is the tsunami service provider interoperability tool that we are developing in EPOS On with the help of 3 tsunami service providers, Italy, Greece, and Turkey. But I want to highlight that this work is done even if they are not directly involved in the project, also with the help of Portugal and France, that are two other tsunami service providers for the NEAM region. What we developed here is the first part of the tool, that is a repository module that includes many data and data sets for the tsunami service operations, like forecast point, bathymetry, earthquake parameters and messages, and some web services that perform the tsunami forecast in both deterministic and probabilistic framework. The Tsunami Service Provider Interoperability Tool will help the tsunami service provider operations to be more interoperable and consistent, increasing the redundancy and the fallback solutions. Here there is the next step where, starting from this repository, we are going to develop a transformer module that will link all of this data to produce enhancement products. The third subtask regards always the tsunami, but not generated by earthquakes, but from atmospheric processes. And this is the task led by RBI and Cléa Denamiel, and regard the prototype service for meteor tsunami warnings. What the subtask achieved up to now is this surrogate model for meteor tsunami at a global scale generated by volcanic eruptions. And in these milestones, you will find the user guide to use the volcano method surrogate model. Subtask 3.1.4 regarding the rapid post-event assessment is led by U-Center in collaboration with other institutions. And the idea is to improve some existing tools and services for a rapid post-assessment of the impact related to earthquakes, and also associated in cascade secondary hazard. I don't want to say two more here because Finn, Helen, and Alicia will present extensively later 3 presentations about these results. The subtask 3.5 regards the expansion of the European seismic risk services to include the environmental impact of earthquakes measured as CO2 emission from damage and reconstructions. They publicly made available the data and made accessible a web platform for the EPOS built environmental data. And this is a results that in terms of embodied carbon seismic risk map for Europe that they produced. Subtasks 3.1.6 and 7 are led by ETH Zurich, and they develop some services and data products for rapid earthquake infographic and earthquake forecasting. And what they achieved up to now, for what concerns the operational earthquake forecasting, is a definition of boundary conditions for the forecast in a time window of 7 days for magnitude earthquakes from 2.5 to 5. And they are going to develop prototypes to visualize these probability changes. And so finally, the subtask 3.1.8 regards the volcanic activity, is led by UCA. And the idea is to provide a prototype service for early ash gas dissipation warning, and in general, a workflow for showing volcanic hazard analysis through a geoportal. Here there is an example of the workflow. And here are some results achieved in terms of different hazards like seismic, ash, and lava flow invasion. The second pillar regards as I said, the interaction with the operational stakeholders, and is led by Giovanna Forlenza. This activity during the first phase of the project was focused on define which is the scene where EPOS can interact with the civil protection. And we had a strategic meeting with the Union Civil Protection Knowledge Network. And now, as Giovanna will describe, we are going to prepare some demonstrators that should be shown to the civil protection, European civil protection. And Giovanna will give a presentation after me. The third pillar regards the methodology for an ethical label for the EPOS services. It was reached a milestone regarding the EPOS community position paper on ethics is led by Silvia Peppoloni and Giuseppe Di Capua. And as a product, they developed a version of the first version of this ethical label that is used to identify and communicate the ethical and societal implications for the product developed within the EPOS framework. Here there is an example, but Giuseppe and Silvia will give a presentation later on where they will explain in details what this ethical label is and how the TCS can contribute on. Finally, the fourth pillar regards the environmental analysis of the EPOS services provision, is led by ISPRA in the person of Carlo Cipolloni, and identify how the technological life cycle of the EPOS research infrastructure can reduce the impacts on the environment, and how the thematic core service can contribute to monitor this. There was 37 macroservice online questionnaires that have been prepared by Carlo, and they are going to be sent. Some of these have been already sent, and some TCS have been already contacted, and Carlo is going to finalize this process. The responses given to each of these questionnaires will be classified and used to calculate the specific SDG indicators that has been identified in this. And that's it from my side. It's a very complex work in this work package, but I'm happy about the work is going on. And I want to leave the floor to Giovanna Forlenza that introduce the scientific product exploitable in evidence-based decision-making. Thank you.
Good morning, everyone. Thanks, Fabrizio. So my presentation will advance some political insight about a critical bridge to disaster risk management, which is how EPOS may contribute to a more effective evidence decision making. So let's start from the scratch. What and how the European framework is organized to deal with disaster risk management. On the right, you see, there is the European Civil Protection Mechanism through which the European Commission is managing the coordination at European, at not European level in case a major catastrophe or very imminent event may happen. So basically the pillar here is the role of the Union Civil Protection, the ERCC, the European Response Coordination Center, which is in charge to coordinate the help inside and outside Europe. But recently, in early 2025, to complement the legislative framework, a new program has been adopted by the European Commission, which is the European Preparedness Union Strategy, thanks to which the European Commission would like to enhance the preparedness, the advancement of scientific inputs for the scope of a more effective disaster risk management. So the core principles are to get an integrated all-hazard approach, all of society approach, and all of governmental approach. So a very transversal approach to cope with a new threat. So how the mechanism is managed by the European Response Coordination Center. So they have a range of very different kind of product and service. So starting from the early warning and monitoring service, they have immediately right after the events, and basically they have a situational room and an awareness room where they understand the scale of the events, the impact of the events in the very first hours right after the event, and they decide if or not to approach these on-demand mapping services. Basically, they are space services to understand better the detail of the impact, vulnerability, and exposure. And at the end of the chain, there are the new scientific partnership. This is a new, not new, not for all of them, because Aristotle is basically established by since 2015. So they are scientific partnership which are teamed up by authority voice. There are experts behind the screen who are able to provide scientific assessment on a 24 basis at the global level. And there is the role of EPOS. So EPOS is exactly at the scientific backbone of Aristotle. For the time being, Aristotle is for the tsunami, volcano, and earthquake communities, supporting the expert to gather all the information before finalizing the expert assessment. So what we are doing in this EPOS zone, we have started to work with the guys here to understand how to position the EPOS tools and services and products in the chain of the disaster risk management. You can see the most of the data, products, and services they are enhancing, implementing with these integrated machine. So there is an eye on integration, interoperability, and multidisciplinarity. And this is very clear for you, for scientists, but maybe not so much catchable for practitioners in disaster risk management. So the idea we had at the beginning of this year, it was to figure out a way to show a demo session to the disaster risk management practitioner. This is a draft, is not definitive. So the attempt is to understand where the products, the services may serve for the scope of the disaster risk management in space and in time. This is a very good exercise to be thought, especially in a multi-hazard scale. And really later our colleagues will give you some insight about how we funnel these some kind of these tools and services in Aristotle, for example. So what is missing and what we have done till now? We have opened a door for making, for creating a connection between EPOS and disaster risk management practitioner. I have to tell you that it's not an easy job because most of the framework are quite formal, especially within the European civil protection mechanism, but we have reached the UN Civil Protection Knowledge Network, which is the formal framework, the formal door where to start discussing with the disaster risk management practitioners. So we have them on our side, and thanks to them, we are now in contact with the SERIS. This is a disaster risk management community. So late June, beginning of July, we will start with the first demo session to show off these tools to some of them. So you will be kept updated on the results. So what is it? I leave you with this very general, but maybe we can talk later in the space for questions. So it's the key points for a possible next evolution of EPOS in the disaster risk management domain are basically lying on three words. So readiness, exploitation, and dialogue. It's clear that sustainability and the scalability of the EPOS products and service must be funneled into operational purpose. You may understand that operational environment has their own language, their own standard. So it's clear that EPOS at certain point have to start dialoguing with these actors and also start thinking how to go out of your policy backbone, because you are talking with your director, but it's clear that you have to start thinking how to contribute to the policy framework, the one I showed you before, so this, especially the European Preparedness Union strategy. Spoiler, this is because in 2028 there will be an adjournment on the mechanism, so for sure this scientific support will be more enhanced, so the role of a research infrastructure can found maybe a different position. And so how EPOS can implement a feedback loop for funnel operational needs into the future development strategy for of the EPOS service. This is an open question that we will see after EPOS on how to deal with. And I finished, so I leave the floor to the next speakers. Thank you.
Thank you, Giovanna. So we go on with the next presentation that will be given by Alex and myself. Alex will start introducing this part of next generation earthquake early warning from public alert to multi-hazard integration. Please, Alex.
Thank you, Antonio. Good afternoon to everybody. I put my glasses. Now I'm okay. So in principle, what we want to... sorry. Good. Now, closer it's worse. So my presentation is more or less related to the current implementation that we have done in EPOS On project in the last months. Let's say that we are core countries, mainly coming from the NFO community, actually all is NFO community. It's Switzerland, Italy, Romania, and Greece that try to implement early warning systems or upgrade them in order to increase their performances. For that, we chose two algorithms and we try to implement them and see how they work and tune them up. One is VS, which is a part of ESE platform, and Presto or Wake Up. ESE is it's a software package that is an extension to SAISComp. It's developed by ETH. And it provides a lot of features that we were interested also in the idea that at a certain moment we will go to public. And what is really nice is that in the moment it offers, let's say, a mobile application that is able to disseminate through it alerts and collect feedback at a certain moment from users. This is how it looks. The first picture in the left is Romania. This is a true event that was broadcasted on the mobile app. Also in Greece, and also an example from Switzerland. These apps now, they are not public. We are just testing them. We try to see how they work. We try to tune up, for example, the magnitude relations that, for example, for Vrancea, which has deep events, need a real calibration and some modifications. In principle, we are, let's say, in an advanced stage of testing and implementing this. Concerning Presto and Wake Up, also, it was deployed in several NFOs. It is very practical also to use this because you can do playbacks, you can test and evaluate performance based on previous earthquakes. For the moment, or in the last 13 years, Vrancea used Presto, a modified version of that software, and just to trigger alerts to the authorities. I will come a little bit later on that. But now in this EPOS Zone, we tried to expand this to the entire country, because not only Vrancea is, of course, it is the most important area in Romania concerning seismicity and damage, but we have also other earthquakes, other seismic active regions. That's strange. In Greece, Presto is also running in real time for several years, and they are testing Quake Up, not in real time, but just evaluating, doing playbacks for previous events to see how the system behaves. The results are excellent. We hope that they will also upgrade and go to Quake Up. This is, let's say, the test area in this case is CRL, which is Corinth Reef Laboratory, also NFO. This is the, let's say, the current general vision about how Presto and Quake Up are implemented. As I have told you, in Romania, we have Presto operational since 2013. This is, so basically we were forced to do that because by the law we are forced to offer alerts to government. So probably it's the only country in Europe that has this obligation. I don't know why, but this is it. We sent alerts to authorities, but also in the last years we tried to make it available to public. So we tested a lot of ways. Some of them were very expensive and they were not sustainable on long term. And now we are having some, let's say, some public channels on Telegram where we have about 25,000 people that receive the alert on their phone. In Greece, they also, using Presto, they have alerts for about 150 earthquakes with magnitude larger than 2, also in the CRL area. But they are, let's say, used only internally, so they are not broadcasted to public. And in Italy, they also have in the crew platform, let's say, the result and all the playbacks and the real-time alerts sent by Presto since 2016, which is close to 1,000 events. And now they are implementing since 2025 and receiving more than 20 alerts just for testing for their NFO. So now we will go to earthquake and tsunami.
Thank you, Alex.
Thank you. Nice.
Thank you. I will continue. I will continue this presentation showing okay, good. Showing a specific application that is, in a sense, crucial for this project because it is an evidence of a good kind, I hope, but you will judge, of a collaboration between two different communities because it's the development of a couplet system for earthquake and tsunami early warning. And of course, they are managed contemporarily by two communities, the Near Fault Observatory and tsunami. The idea is to answer to that question. So can and in which condition, to what extent the earthquake early warning system might actually support a multi-hazard view in disaster risk management? Of course, the first easy prompt answer is to say, okay, when the earthquakes occur very close to the coast, because in those cases, we can have very dense networks around the source, or despite affected by some azimuthal gap. But on the other hand, we have also reduced lead time to effectively protect the areas, the coastal areas from the inundation. And therefore, we tested our platform, let's say, in the Mediterranean basin, where we have these conditions. For instance, we have the example of Samos earthquakes, for which we have executed a playback of the platform, but we have possible situations also like the Messina Strait, where we have this dense network, but events that can occur offshore. So the idea of this platform is very easy, is simply a cascading workflow where the output from Quake App that has been just introduced by Alex, in particular the location and the magnitudes, are used to feed the PTF, probabilistic tsunami forecasting approach, to provide tsunami alerts, in particular to provide an anticipated alert with respect to the one that is then triggered by the standard used tool that is earliest. PTF is a tool for tsunami early warning that is currently in implementation at the Tsunami Warning Center of the Mediterranean, managed by INGV, that exploiting these source parameters properly select some pre-calculated inundation scenarios with weights that depends on the uncertainties on these estimates, and then provide the alerts depending on the probability of exceedance of a certain level of inundation. It's a very good tool because it is able to provide and to propagate the uncertainties on the source propagation, on the source estimation into the alerts. And let's look very rapidly to the results of this test. From the first test that we performed in playback on the earthquake of Samos, we obtained a first possible alerts given by Quake Up 10 seconds after the earthquake, the occurrence, the origin time, but of course with very large prediction errors, both in terms of epicentral and depth. However, after 40 seconds, we have a very robust and stable estimates and errors that are, however, smaller with respect to the errors from the same estimates from earliest, considering that these estimates arrive after about 3 minutes. The same result also for magnitude estimation. We have a very good estimation consistent with the error, and again after about 40 seconds. And in terms of shaking, we could have that more than 90% of the networks were able to provide a successful alert at the network around the area of Samos. Here is the outcome of the second part of the workflow, the outcome of PTF. This has been already presented and shown by Fabrizio in the first presentation. It uses the prediction from Quake Up, and here the alerts are based on the maximum wave amplitude that has the 10% of probability of being exceeded using the 90th percentile. This is another great advantage of this method, because the decision makers can decide how much conservative they want this forecast, and then it is easy to map these values of height on level of warning depending on predicted inundation level. The response was given after about 40 seconds, so we are about 1 minute and 20 seconds after the occurrence of the event. In terms of the hazard curves, and then in terms of alerts, we see that the prediction from Quake Up system and earliest were basically the same, but looking at the position of the wavefronts when the first alert is available, we can see a very great gain in terms of lead time that can make this system really efficient in protect the coastal areas when earthquakes occur in an archipelago like this one, or very close to great, very populated cities like Catania in the Messina Strait. We also used the test of Catania, where we could produce a very great set of synthetic simulation to test the sensitivity and robustness of our results in terms of prediction error for the source parameters and time to get a stable solution, respectively on the top and on the bottom, and varying the source on considering a very important network degradation. We see that from these histograms, The results are, however, of the same orders of magnitude of the prediction that we got in the worst scenario cases, both for Samos and Messina case. I think that time is running out very rapidly. Okay, we have presented everything here, so I will not give other details about the summary. I want only to say that the just presented approach that show this integration between earthquake and tsunami early warning will be soon developed as in the shape of a demonstrators to be presented at European Civil Protection Mechanism initiatives in disaster risk management within the activity that has been just presented by Fabrizio and Giovanna. So thank you. Okay. Yes.
So it's really a comment. So you presented results from activities cross TCS. So
Yes.
again, I think this is something that the community has to discuss, how to then visualize, how to integrate this kind of results on the EPOS platform. So we have to find a way in which, and this is not the first time today that we are talking about data that might be cross TCS. So we really need to discuss all together how we want to visualize, present, integrate, and make accessible this kind of data. And thank you. And okay, for Giovanna, but maybe later on during the question and answer. Okay, thank you.
Thank you, Lily. And we can go to the next talk by Finn Lovold that will present this integrated tsunami impact assessment workflow within Aristotle. So please, Finn, floor and remote is yours.
Okay, hello everybody. So I'm going to present to you a study that is truly quite interdisciplinary, but still within the TCS tsunami. So it's an integrated impact assessment workflow where we are using some of the services from mainly the tsunami TCS to enable an emergency management. And this work is mainly a collaboration between NGI, where I work, University of Malaga, and INGV, but also the tsunami service providers that work within the Aristotle consortium. So the background here is that we do have the Aristotle network acting in terms of the ERCC, as Giovanna nicely outlined in the previous talk. Aristotle is tasked to perform post-event assessments. Analysis within 3 hours after an event has occurred, and this is acting across many perils, from hydromet hazards to seismic and tsunami hazards. And within our domain, earthquakes and tsunamis, there are services to provide the impact analysis for earthquakes. Helen will provide a presentation on this later. We have the USGS pager. But we did not have anything like that for tsunamis. And there are no other players internationally either that covers this. So we needed to provide something that could tell us something that moves towards tsunami impact analysis. And for this, we are doing tsunami exposure analysis, trying to analyze how many people that will be exposed to tsunami quickly after it has occurred. So this is the objective, is to provide a global model that can do that. Technically here, we are looking at the global geographical coverage. The service should work globally. It's an institutional collaboration, so we have the tsunami service providers, the TSPs, that operates the service on a daily basis. We have University of Malaga that develops the tsunami propagation codes and enables it through the SPADA platform of Aristotle, so the users can deploy it and use it automatically when an event happens, and NGI that has done this recent development that comes on top of this and tie this together into an exposure analysis service. The motivation was also to be able to leverage development within tsunami hazard analysis globally that has been done for other types of analysis, such as probabilistic tsunami hazard analysis. And the service is now, as I will explain, developed. It's finalized and is being rolled out. And it's globally unique. And it combines these type of things, as I said. and now it's becoming operational. The first part of this is one of the services within EPOS TCS. It's the Tsunami High Sea Code. It's a shallow water model, so really quite a standard type of tsunami model, but it's very efficient, being implemented on GPUs. So it's possible to run this faster than real time and give tsunami impact inputs, tsunami propagation results within a few minutes after an event has occurred, depending, of course, on how large scales you're looking at. And it's also operated through SPADA. And it can also be set in a little bit, domain size can be set arbitrary. And you can execute these tsunami simulations within a short amount of time. This delivers several types of outputs. It delivers the field, so like you see in the map here, the tsunami amplitudes as a function of the distance. It delivers the travel time, but also time series close to the shoreline that we use to estimate the exposure of the population later. The next step here is another EPOS service, the Global Amplification Factor. This is also another service that is available through GitHub and through being enabled through GeoInquire. And this is a service that takes the input from Tsunami High Sea. It estimates the tsunami maximum inundation height at the shoreline, because the propagation code cannot do that so efficiently and over such a large area as a global service requires. This necessitates a non-local approach. So we have a lookup table where we store simulations, and we test these towards the time series from Tsunami High Sea, and we calculate the amplification factors that should represent more or less something like the run-up height or the maximum inundation height close to the site. Because this is a non-local approach, it carries a large uncertainties. We have calibrated it towards higher resolution models, and we have tried to quantify their bias and how much variability these models give us, both from site to site, but also within the site. And we estimate this as an uncertainty in our model, which we don't have in the amplification factor model. And we add this on top of the estimate of the mean values. This is now taken in another quite coarse-grained model, which is a so-called bathtub-like approach, where we take the maximum inundation height that we have developed from the AMP factors. We extrapolate them over an open source DEM. In this case, it's a dataset called TESA DEM. We assume a small friction loss over the inland flow, and we discretize the inundation, again, in lookup tables that we have stored. And we link this to the inundation heights. So we take the inundation heights, we drag them along until the contours that are similar from the TESA DEM, and we have these patches of inundation that you see in the lower right-hand corner. This is then combined with exposure estimates from the global human settlement layer to calculate the exposure, simply integrating inundation with these type of data sets. So it again applies open data sets that we have on a 30-meter resolution. So combined, just in a summary, we have this setup. We have the tsunami simulation from the High Sea service and the amplification factor service from EPOS. We have the time series analysis, which is also embedded in the amplification factor service, along with the uncertainty treatment. And these different steps are executed in SPADA with the operators. And then we have the exposure that is being estimated first via the lookup table for the inundation and the exposure estimation on land. This can probably also be also developed into other types of data sets, such as buildings, etc. But right now it's population exposure. So it's a 24/7 service that can be activated by Aristotle operator on duty. So this is always working. It's been first run by the TSP operator, the Tsunami High Sea service. So it's done really in 2 steps. And then there's another service that the TSP operator has to activate, and that's the exposure service. So you first have to generate the tsunami model, and then you can take the time series and generate the exposure. It's run in Azure Cloud through a Rabbit MQ service that automatically can trigger it. And it automatically generates these type of maps, as you see for Tohoku here, inundation maps. And it generates tables of exposed people from each country that's affected by the tsunami. It also gives uncertainty ranges depending on certain predetermined and certain percentile values. The last step that has been very important for us is to actually test how this procedure works, because there are many different steps here that are relatively rough, and we have therefore tested this towards simulations of earthquakes, tsunamis for 4 different events. The first one is the Tohoku 2011 event to the left-hand side, where we have used an inverted source from Fabrizio Romano here, and compared the outputs from inundation heights and exposure numbers for Japan for the Tohoku event. The second one is the Indian Ocean tsunami, where we have done the same type of exercise, but for a different source from Fuji et al. And finally, we have done some quite quick analysis also to test how the inundation heights compare for the Maule event in Chile in 2010 and the more recent Noto event in Japan, which constitutes a smaller earthquake. For Tohoku, we get actually a remarkable good match for the inundation heights and also, as I will show in a minute, for exposure. When we look at the calculated median heights of the maximum inundation height and the mean height, which is a little bit higher because of this uncertainty in the model, and the observed values, we see that most of these fall within the range of the maximum inundation height observations in the field, despite being somehow larger in certain areas. So really in this case, with a good inverted source, you can see that even with a rough model, we can quite well estimate the inundation for this case. We see here how also the uncertainties affect the results to these 3 panels, the median value inundation in the upper left and the mean in the middle and the 84th percentile in the lower right. So we see that the inundations that we are getting with this is highly uncertain. There's a large spread in them, and also the exposure estimates will give a large spread. And this will vary from case to case. For the median value in this case, we almost got it spot on. So we had, looking into reports from Japan for the households, we are close to 2.5 million people, both in the observations and the median values that we calculate. For the Indian Ocean tsunami, we are not getting quite as good match. We have a good agreement in the inundation for Indonesia, Thailand, and the Maldives, but we are underestimating for this source the exposure in Sri Lanka and India. Is mainly due to the source inversion, we think, because really the factor that determines the inundation here is the amplification factor, and they're quite high for India and Sri Lanka. So it's very likely that with other sources we could do better. We see here also for the Lokna and the Banda Aceh area, we need to go up to a median, above the median value, we need to go to the mean value for the inundation to really match the area that is inundated. And for higher percentiles, we get an overestimation. For Maule and Noto, we didn't do as careful analysis, but we see also here that the inundation heights and that we are getting from the model is relatively well aligned on the average sense with the observed values, although overestimating a little bit for the Maule event. And again, with quite large uncertainty bars, as you see with this blue, yellow, and red curves on top of the bars that are observed. So to just wrap up, this is an example how we can use EPOS services, combine them, work together between institutions, and then actually use it as a case to do something that can be used operationally. It necessitates definitely that institutions collaborate and make accessible their different models to be able to tie them together. And it's a service that is right now being put into use for Aristotle, and shows that also this Aristotle network can be an accelerator for actual service implementation and use in practical situations. Thank you.
Thanks, Finn. Yes, Stefano, please.
Thank you, Finn. Beautiful presentation. I feel that I need to make a comment in my capacity of a coordinator of one of those tsunami service providers. this is the way to go ahead, but we must point out that this information at the moment in Europe is not publicly available, so to avoid any misunderstanding here. So this is an information that, like Giovanna explained, is provided to the DG ECO and to the authorities, because we, as TSPs, provide our alerts only to the authorities for the moment. There are no public messages. And then these messages are managed at the national level. So we have to be, but Lily, you are aware of that, but we have to be very careful to respect fully this chain until there won't be, probably in the near future, public messages. But consider that even if yours is a post-event assessment, it happens with an event still ongoing. And so with the tsunami warning and response operations still ongoing. That said, of course, I'm a fan and a supporter, and I think that we should also strive to introduce the probabilistic forecasting that Antonio is already using to have everything in the chain. Thank you.
No, thank you, Stefano, for this clarification. This is exactly the comment I wanted to make, and I said, okay, after Giovanna's presentation, then I said, maybe I make later, but indeed, the reason why we are together with Giovanna and with the leaders of the work package doing such a delicate and not that easy work of talking at a European level with the civil protections is indeed because we would like to demonstrate that EPOS has the capability, the potentiality to support this kind of activities and can produce this kind of products, but exactly as you said, at the moment we are not delivering these products. So this is the goal of the work package, to demonstrate that EPOS has the capability to do that. And then together with Giovanna, we are working with the civil protection at European level to understand if and how we can then share this kind of products with them. EPOS, since the very beginning, was very, very clear. We do not interact with national civil protections because the commitment is at national level. So the national research organizations contributing to EPOS, some of them have commitment with the civil protections. So it's not up to EPOS to interfere in this kind of relations. What we want to demonstrate with EPOS is that in EPOS we have data, we have services that, if properly combined, as it was demonstrated today, can be useful for policymakers and for decision makers. But that's the point.
Okay, thank you again, Finn, and thank you, Stefano and Lily, for the comments. Let's go on with the next presentation. Helen is there. Okay, so please, she will present this rapid earthquake impact assessment, understanding uncertainty from source and shake map variability, please.
Thanks. Good afternoon, everyone. So this is another Aristotle service presentation, and picking up from Stefano's comment just now, we're also not making our rapid impact, earthquake impact assessments publicly available. But I wanted to talk to you through in this presentation really about some of the challenges when doing that rapid impact assessment in an operational environment, especially what are a lot of the uncertainties that we find. So just to make sure that we're all on the same page, what are we talking about when we talk about rapid earthquake impact assessment? We're talking about using earthquake observations together with our information on exposure. And in here, we're focusing on buildings where people live and where they work. So how the exposure information then interacts with those earthquakes, the vulnerability of those buildings. So that's the probability of the buildings being damaged and generating losses and various impacts. And we're doing that really immediately, as Finn mentioned, within 3 hours, at least as a first version, within an event. We want to share those impacts on the human, physical, and economic impact assessments to support emergency response and other situational awareness reports. So this is within EPOS on projects, as mentioned before, in subtask 3.14. but also task 3.2 because we're providing this service and providing these outputs to Aristotle, which has been mentioned, and other stakeholders. So I don't need to explain Aristotle and the role of the consortium there, but just to mention that we put together this slide mainly with Licha, who's going to present afterwards from INGV. They are part of the operational team in Aristotle, so they're providing the 24/7 support together with other partners as well. But we at GEM, we're providing the rapid earthquake impact assessment, but we're not operational. But we need to make sure that our models can be used in that operational context and that the results of that impact assessment can go into the reports that are shared with the ERCC. But we've found difficulties in making these automated assessments of the impacts of earthquakes. And this is where we've sort of looked into things into more detail and should we at least explain how those uncertainties affect our impact assessments. And so that's sort of what I want to talk you through in this presentation. So how do we assess those impacts? We have a software called the OpenQuake Engine. It's an open source software for earthquake hazard and risk assessment. And so we are bringing in rapidly an assessment of the ground shaking from the earthquake. So we could bring in a shake map, it could be the USGS shake map, or it could be a national shake map or the European shake map system. We could also, as an alternative, try and calculate that shake map ourselves. So we can bring in a rupture, we can use ground motion models. So that's the sort of the dynamic part of the process, bringing in that event and the information we have about the earthquake. At the same time, we have these static databases. We have our global exposure model where we've already modeled the built environment, the buildings around the world, and we have the vulnerability functions, so the characteristics of the buildings and how it impacts their likelihood of damage. So when an earthquake occurs, we can zoom in on the area of interest and sort of cut down that exposure model, pick up the vulnerability functions of importance, and rapidly calculate the impacts. And when we talk about impacts, we're talking about the number of buildings which are lost, which are severely damaged, that they need to be replaced, the area of those buildings, the economic impact, what's the cost to repair that damage, the fatalities, the number of injured people, the number of displaced people. And so we're not just calculating the total numbers, but we're also looking at that spatial variation, so we can produce maps which show you how those various impact parameters vary spatially. And so we're currently putting together an automated PDF. You may be familiar with the pager, the USGS pager system, which is like this one pager. We're looking to do something similar to show those different impacts, to have a table which can go directly into that report that I showed you before. So I wanted to talk about the different ways that we bring in the ground shaking and the impacts that has on the assessment. So we can bring, as I said before, the shake map directly from USGS. So here we already know the ground shaking. We don't need to do anything further. But we may not want to use that shake map. We may have other information. We may want to do things slightly differently. So in the OpenQuake engine, we can model the ground shaking ourselves. And there's various ways we can do that. We can use a point rupture. Now, this is often what USGS does immediately. So immediately in the first minutes, even hours, it's modeling the earthquake just as a simple point rupture. We can go and look at the nodal planes and try and make our own rupture ourselves. Within a few hours, sometimes days, we might get a finite rupture from inversion that USGS puts out. We could also go into our probabilistic seismic hazard models that we've already built up for the whole world and see, okay, if I have an earthquake of that magnitude at that location, what does my hazard model tell me that the likely rupture is going to be? So I can build the rupture very quickly that way as well. Or I can just build a very simple rupture based on typical input parameters for that region, for the magnitude, strike, rake, slip, dip. There's a lot of uncertainties around that whole process of building a rupture and calculating the ground motions. We have uncertainties in what is the magnitude of that earthquake? What is the location? What is the fault rupture geometry? Which of those different options should I use? Once we have the rupture, we then want to calculate the ground shaking, but we have epistemic uncertainties. Which ground motion model should I use? And if I pick a ground motion model, what about the aleatory variability in that ground motion model? How is that affecting my impacts? What if I have people providing, did you feel it data and macroseismic intensity data? How can I bring that in and convert it to ground motion? And what are the uncertainties there? Ideally, I want to use strong ground motion recordings, but sometimes there can be unreliable recordings, and what could their impacts be? So I'm just going to give you some examples of the impacts of these various uncertainties. So there was an earthquake last year in Afghanistan. magnitude 6, 1st of September 2025. And initially, USGS, as you see if this works. Yeah, was giving the epicenter down here near the town of Jalalabad. So our very initial spatial damage pattern, damage distribution is the map you see on the left there. So this was the map that went into, would have gone into the report to the ERCC. But following some hours, some days, other agencies providing the epicentral location, you can see it's moved significantly. And we then updated our assessments with that revised epicentral location. It gives a very different outlook of where the largest damage is going to be. And USGS even changed the name of the earthquake because of that change in location. If we look at the rupture geometry, I mentioned before that often USGS starts with a point source. So let's take the Turkey earthquake, magnitude 7.8 from 2023. So that very first shake map modeling as a point source, you can see where the ground shaking is going to be distributed. But even just modeling that initially with a simple planar rupture, what would be the likely dimensions of such a magnitude earthquake? We get a very different distribution of ground shaking. We could also have gone into our PSHA model. So this is the ESHM20 model in Europe and picked up what would have been the most likely rupture that model tells us in that region. And we can compare it then to what the rupture that came out maybe some days or weeks or months later from studying, we'll call that our benchmark rupture. And we can see that we're going to get a much closer distribution of the shaking from that PSHA-based model. So what impacts do these different assumptions on the rupture make on the losses that we assess? So we've looked at various earthquakes. We've looked at if I model it as a point source, a planar rupture, or if I take the PSHA model, how much does what's the percentage difference between the impact from those different assumptions and with our benchmark rupture? So you can see that in most cases, going to the PSHA model and using the rupture, so that's that light brown, GEES is the name of the software that we use to do this, is giving us losses that are much closer to that benchmark rupture. Let's look at the ground motion variability, the aleatory variability. So what I'm trying to show you on this figure here is along the x-axis, you have what's called the inter-event variability. So some earthquakes lead to larger ground motions on average everywhere or lower ground motions on average everywhere. And so we could in an earthquake with very much larger 3 standard deviations above the median everywhere, we could have up to 2,000 fatalities being estimated. But if instead that was an earthquake that on average generates much lower ground motions, we could be down to 0. You can see that massive impact we can have just from that bias, that aleatory, inter-event variability. We can also look at the within earthquake variability, the intra-event variability, and that's what we're showing for each inter-event standard deviation. We can look at truncating that within event variability and how does that change the losses. And we can somehow constrain all of this uncertainty. We can do that through ground motion recordings. So we can start to bring in station data and condition our ground motion fields. That's what a shake map does. And we can use that ground motion data to understand, okay, is this a higher than average or a lower than average earthquake? What is that bias? And then we can also condition ground motion fields and reduce our within earthquake variability. And we've seen in past earthquakes, for example, in New Zealand here, that when we do bring in that station data, we can get a mean loss, which was much closer to the actual recorded losses. But what if we don't have stations in our region? Are there other data sources we can use to try and constrain those ground motion fields? Can we use macroseismic intensity or did you feel it data? And that's what ShakeMap does. But as you can see from this figure, so on the y-axis, macroseismic intensity, it's been converted to the ground shaking information. This is peak ground acceleration. Look at how wide that uncertainty is, in the conversion from macroseismic intensity to the instrumental intensity, peak ground acceleration, spectral acceleration. So we'd have to propagate that uncertainty. And so how much is it really helping us? So we much prefer to use stations if we have them. But there are cases where stations have potentially led to errors or malfunctioned. And we had an unusual situation recently with an Istanbul event in 2025, where you can see there where the epicenter is here. and there's a natural reduction of the ground shaking as we go further away from the epicenter. But then there's this island of very high ground motion quite far from the epicenter due to the station, which was giving very large values of ground shaking. We noticed that this station was being used in the USGS shake maps, but was not being used in the local shake maps. So perhaps it malfunctioned, we don't know. But these are all the types of things that you want to look into more detail and potentially manipulate and change during the process. So just to sort of end, I wanted to give you some examples of how have our assessments changed over time as this various different sources of information has arrived. So looking at the Myanmar earthquake from last year, you can see, and if you consider that we're talking about around here, 3 hours for the report to Aristotle. So you can see our very first estimate, which was based on a point source. We had a much lower estimate of the fatalities, which then started to grow as we brought in information on the rupture, as we changed the rupture from a simple rupture based on a nodal plane to bringing in our knowledge from the hazard model, all the way up to when USGS provided their finite rupture. And it wasn't just the impact on the total numbers, but as I showed before, the spatial distribution is also varying a lot. Here's the Afghanistan example I showed you before. Here, we're not seeing such a massive change in the total numbers of fatalities, but as mentioned before, the spatial variation changed a lot. This is an example of the earthquake in the Philippines, again from last year, where the difference from one version to the other didn't come from the ground shaking, but it came from us looking into a little bit more detail into our exposure and vulnerability models. So we're constantly updating and improving those models, but obviously when an earthquake occurs, it really shines a light on that region and we look into a bit more detail, and we understood that this earthquake, we were putting too many people inside the commercial and industrial buildings. We were treating their vulnerability as too high. And so by starting to modify some of those assumptions, we brought the losses down. We had an example in Venezuela last year where there's a ground motion model, Zhao et al., some of you might be familiar with it, which is consistently giving impacts which are an order of magnitude higher than any others. And so we're really stopping to use that ground motion model. And so this was another reason for a reduction. And then in Istanbul, there was a removal of that station, which we believed was malfunctioning. So just a few takeaways I wanted to leave you with was that there's lots of uncertainties when we do these impact assessments, especially in those first few hours, and we're trying to rely on an automated procedure where we're not bringing in expert input, and we're just directly using, for example, the USGS shake map. And so we do believe that you almost always need that expert input. That takes time. We built this impact platform that I talked to you about to allow for that advanced changes. There's advanced user inputs to be put in to actually plot in a specific rupture, choose the ground motion models, bring in station data, and so on. Obviously, the more information we can get in those early stages, the better we can constrain the ground motions. We can look to using Did You Feel It and macroseismic impact data, but maybe there's other sources that we might want to look to, satellite imagery, crowdsourced photos, and so this is something that we plan to do in the future. But even when we have very good knowledge on the ground shaking, we've reduced the uncertainties as much as possible. There are uncertainties in our exposure and our vulnerability models, so we do need to continue to test and improve and validate those. And so going forward, we have a global earthquake impact database, which was developed also as part of the GeoInquire project. And so we are planning, as we are running our impact platform, to bring some of the model inputs and to share them through this impact database. So we're not planning to share the outputs and our assessments of the loss, but bring in those inputs to the OpenQuake engine, the ruptures, the ground motion models. And we're also expanding this database going back in the past as well with historical events. And this becomes a very useful resource for testing those exposure and vulnerability models. And so if you're interested, there's a paper in Earthquake Spectre that's recently been published. And with that, I'll thank you.
Thank you, Ellen. Now I leave the floor to Licia Faenza, that will talk about operational shake map services, application, and societal impact.
Okay, thank you, everyone. Okay, so my presentation of today is about how we implemented the workflow at INGV for ShakeMap. Maybe all of you know that ShakeMap is tools that combine the information about the events in terms of location and magnitude with the real data, and with the information we have, this is neurological information we have in the area as the ground motion model and the VS30. So ShakeMap deliver maps in terms of PGA, PGV, and intensity. Intensity is the map that is largely used by the not expert people, for common people, for journalists, for civil defense authority, because it's the map that easily show the impact of an event. We also provide map in other quantity. We are in contact with our colleague from engineer sites to understand what are they need to provide maps that can be useful for them. INGV delivers ShakeMap for all the event with magnitude higher than 3 for all the territory till 2008. We have a web page, a dedicated website, pardon. And for each event, you can download all the product we calculate, not only the map, but also the files in different format, for instance, shape file, raster file, grid file, the uncertainty map as well. So everybody can use the result and in other tools. And besides this, we also provide the input side that we use. So we provide also the peak ground motion that we use in the analysis and information about the ground motion model and the VS30 model that we use. In this way, another operator can run ShakeMap and obtain the same result as us. And this is for us important because we provide a complete and transparent procedure. As already been highlighted by Alan before, ShakeMap is about its essence an evolution. It's a product that is an evolution. When new information becomes available, we recalculate ShakeMap in an automatic way. So at INGV, we deliver the ShakeMap just after the INGV Seismic Center lie the location. That is, in average, 15 minutes, 20 after the event occurrence. Then there is an update that is automatic, and that is become automatic when more data become available. And the last update is basically after a couple of days when we receive the data that have been humanly checked by the ESM, European Strong Motion Engineering Strong Motion Database. As Alan said, sometimes also instrumental data can have error. There is a sanity check within ShakeMap to exclude the error, the event that are far away from the prediction. In any case, if there are revised value, we prefer them. And this is an example. This is Campi Flegrei. At INGV, we tailored the ShakeMap for the Italian territory. So we use the most updated ground motion model available for Italy. And also we have specific area for volcanic set. And of course, this also part in an evolution. When new ground motion model become available, we test them and see if they can provide some improvement in the evaluation of the shaking. So it's not, I believe that it's not easy to see. But here in the, I don't know if it's working. See, in the bottom left, right, there is the version of the ShakeMap with the time in which the ShakeMap is calculated. So this is the first one, and after 30 minutes we have the second one because new data become available. And then there is also a revised location of the events. So this is implied in new ShakeMap, and this is the last one, version number 10. A couple of, I think, 2 days later. We keep all the track of all these versions. They are available so people can test them, see the difference, how ShakeMap change as far as more information become available. ShakeMap has been developed for instrumental seismicity. So we use location, magnitude and real data, ground motion model, the conversion of ground motion model into intensity to have the intensity map, the final fault when is available. But also we decided to work with the historical pre-instrumental data. So we calculate the shake map for all the all the pre-instrumental event we have in the catalog. And we use the origin, time, location, and mind from the Catalogo Parametrico Italiano, which is the Italian parametric catalog, the macroseismic intensity from the macroseismic database. We convert the intensity into ground motion model. We adopt the final fault when available, and so we were able to reconstruct the ground shaking of past events. All these shake map are available in the shake map webpage, but also in the archive of historical seismicity, which is ahead, because we think that this product is a bridge between the two communities, the one that is working in real-time seismology and the one that is working in historical seismology. So the two communities can fund product from different sides. And this is only an example. This is the Amatrice event, this one. The Amatrice event, a 6.0 event. This is an event of 1703, magnitude 6.7, basically in the same area. We are in a process right now in which we are improving our web page. We want to add more layer, make it nicer, easier to navigate and to understand, especially for non-technical people. And so we also improve the visualization tools. We know that the intensity map is the map that people look at, they want us to see because they want that very easy to understand. So this will be the new homepage of Shake Map. And also we have new products. First of all, we are working on the integration of Isentitul Terremoto, which is the Italian analogous of Did You Feel It? And that's the inclusion of this data is something that we are still working on. We are making a lot of tests to understand the improvement they can provide to the maps. They definitely can improve the shaking in area with not dense coverage, not from the station point of view, and for medium-sized events. And of course, every time you add any information on the map will change. So we wanted to understand how this change, we want to quantify this change and if this change improved the shake map. So we, after several tests, a lot of statistics behind, we align in the use of intensity data that are derived by at least 3 questionnaires with the intensity level lower than 6 or 6.5. We are still working on this. And we include this data with uncertainties that's been calculated by our partner from INGV. I forgot to say that also this kind of work also done with the aim to combine 2 different products from INGV and to make them also a connection among all them. Also in the web page, we wanted to show what we call the maximum recorded in shaking in different time frame. This is an example for the last 10 years. So we grid Italy and we keep the maximum along over the shake map. So this is the maximum, if you look at the intensity in the last 10 years in Italy. But you can also do this for the historical event. This is the event with magnitude higher than 6 in the last 1,000 years. And this is the intensity map. Of course, this has to be improved. We wanted to also calculate the shake map for magnitude around 5 and above. So today I'll show you how at INGV we implemented shake map. And is an evolutionary product that improves as more data become available and also when the location and the magnitude have been revised. With the historical shake map, we provide also tools for the risk for support risk modeling for past events. We are in the way to the integration of sentito il terremoto within ShakeMap to better constrain the shaking in area with not dense station coverage. And we also try to make our website more friendly. We think that ShakeMap can support the authority when a big event occurs to help the decision maker. And also with the historical analysis can contribute to the long-term seismic hazard analysis. And in real time, it provides reliable tools for the quantification of the shaking, and also can be used in outreach because it can help people, general public, to understand, to be a bit more aware about the impact of an event. And I thank you.
I have a very quick question. Sorry, Alicia. So are these data actually available? Or okay, so are they?
They are totally available from our webpage. Okay. Everybody can download them. They are public. I forgot to say that we use the integrate network that is available from the INGV. So we keep all the stations that are available for location in our ShakeMap.
Are you planning to make it available also through the EPOS platform?
Yes.
Okay.
Of course, there's no problem for this.
Okay.
Yeah.
Okay. So let's work on that.
Oh, yeah.
Thank you.
Thank you, Licia. And now the last presentation of the session about the ethical label, as anticipated before. Please, Giuseppe Di Capua.
Okay, thank you. Hello, everyone. My name is Giuseppe Di Capua from INGV Rome, and today I will present the ethical label, a tool we are developing within the EPOS project in Work Package 3, Task 3.3. The aim of this work is to introduce a structured approach to identify and communicate the ethical and social aspects or implications of scientific products and services in EPOS. The ethical label was developed through a process of refinement and standardization. We started from an initial version developed in the European project EMVRI Plus, and then tailored it specifically for EPOS data products and services. A key step was the development of a categorization scheme based on predefined fields, which allows descriptions to be consistent, comparable, and standardized across the EPOS community. And this approach would ensure that different types of scientific outputs can be described in a similar way, facilitating understanding and evaluation. The ethical label serves several important objectives. First, it provides a structured framework to analyze key information about scientific outputs, including expected impacts and possible ethical or misuse risks. Second, it supports transparent communication with both internal and external stakeholders, and this transparency can help strengthening trust and dialogue between researchers, institutions, policymakers, and society. And finally, the label assists researchers and technicians in identifying the scientific, social, and ethical aspects and implications of their work, promoting responsible innovation aligned with EPOS values and FAIR principles. Another important aspect of the label is its role in promoting responsible and sustainable use of scientific data products, and services. The label would encourage users to consider not only the technical aspects of data, but also their broader impacts. And in particular, it supports responsible and informed use of EPOS data, protection of the rights of involved parties, and attention to social and environmental issues. To achieve this, the labeling scheme includes several sections that describe the characteristics and implications of a given product or service. This slide shows the overall concept of the ethical label summarized in a visual representation. The idea is to provide a synthetic, as I said, but structured description of a scientific data products and service. In practice, the label functions as a concise information framework that helps users quickly understand key aspects such as what the product is, who may use it, what impacts it may generate, and what potential risks should be considered. The label also includes a validation process. Obviously, this is still at the proposal stage, and this process would ensure traceability and accountability through different phases, such as completion by the product creator or designated contact person, internal ethical review by the EPOS Ethics Working Group, and the approval by the ethical board of EPOS ERIC. Let's go into more detail. I will also show you an example of a compilation, and for this purpose, I would like also to thank Fabrizio Romano for providing the example related to the NEAMTHM18. It's a very complicated acronym. That is a long-term probabilistic hazard model for tsunamis generated by earthquakes. It covers the coastlines of the northeastern Atlantic, the Mediterranean, and the connected seas. The first section of the label concerns general information. So this includes basic elements such as the name of the product, the authors or contact persons, the completion date and version, and links to the datasets or data product or service. And as you can see, the fields are filled with general information about the example. And the second section describes the type of product. So EPOS outputs can take many forms, such as datasets, databases, software tools, models and simulation systems, web services or data portals, technological devices, guidelines, protocols, and educational materials. And by identifying the product type, the label helps users understand the nature and intending function of the output. And for the product for which we are giving the example, it would fall under the categories of simulation and numerical models, API, web service, data portal, and the field website. Another important aspect is the identification of the scientific and technological areas relevant to the product that should be labeled. And these may include earth environmental sciences, data and computational science, engineering and technology, biosciences, and educational or methodological developments. And this classification helps contextualize the product within its scientific domain and methodological framework. And in these slides, you can see how the required fields have been filled in for the example I'm presenting. So our hazard model falls within the fields highlighted here, in particular under earth environmental sciences and data science and computational science. The label also highlights the social and public relevance of the EPOS product. For example, it may relate to disaster risk management and risk prevention, public safety and civil protection, policy and governance, education and outreach, or socioeconomic impacts. And this section is particularly important because it connects scientific outputs with their potential societal applications and benefits. And here you can see how this part of the label has been filled in for our example. The social implications of this product are numerous and concern all the areas included in this section of the label, and then you can see also the subsection. Another key component concern who will use the product and how it can be accessed. Potential users may include researchers and academic institutions, governmental agencies, industry and professionals, educators and students, or the broader public. As regards this section of the label, you can see the several fields have been selected, indicating a broad range of potential users of the product and consequently also a wide range of possible impacts of this product. The label also specifies the accessibility conditions. This may include open access, where the resource is freely available to everyone, open access with registration, where users must create an account, partial access, where only certain subsets of data are available, metadata-only access, where only descriptive information can be consulted, embargoed access, where the resource will become available after a certain date, and restricted access, where access is limited and requires specific authorization. And these information help users clearly understand how the resource can be accessed and under what conditions. In our example, we are considering a product that is open access, meaning that it provides full and barrier-free access. A central part of the label is the description of the expected impacts of the product. And these impacts may be scientific and technological, environmental, societal and educational, economic and industrial, related to policy and governance, or related to project and infrastructure management. And these sections help clarify how a product may contribute to knowledge advancement, societal benefits, or decision-making processes. In our example, we can observe the numerous impacts, including potential ones that this product highlights across all the subsections. This implies that the product does not have consequences limited to a single domain, but may generate effects at different levels and for different categories of users, as we have already seen. And therefore, its assessment requires a multidimensional perspective capable of considering both the opportunities and the possible risks associated with its use. To this aim, another very important section of the label concerns potential ethical issues or misuse risks. Even if only theoretical, possible risks may include misuse or manipulation of data, misinterpretation of or false alarms, unauthorized commercial use, privacy violations, or harmful impacts on communities or environments. And however, the list is quite extensive. By explicitly identifying these risks, the ethical label promotes responsible awareness and risk mitigation in the use of data products, and services. This is the results of the label completion in our example. As you can see, several fields are highlighted. This is not surprising, since we have already seen that the potential users are numerous, as are the possible impacts of the product. And the more widely a product can be used, the more context it enters. And this naturally increases the range of possible effects, benefits, and risks. I will give you a few seconds to look at the highlighted fields. So, to conclude, the ethical label represents a practical tool to integrate ethical, social, and in some ways also environmental considerations into scientific data product, and services. By providing an easy and structured description of impacts, uses, and risks, the label should help promote responsible science, transparency, and stronger connections between EPOS and society. We look forward to receiving your feedback. Thank you.
Thank you, Giuseppe. And just one quick comment. The example that Giuseppe showed, of course, is an example, and it was compiled just from one person, myself. And of course, I believe that such a kind of process should be a collaborative one and involve more people than just one. So if you have any comments for Giuseppe or Silvia, please. Stefano?
Yes, indeed, Fabrizio. We noticed some errors in the compilation, but I wonder how much of that information is already present in the metadata, in the DMP, etc. So which part of the process can be linked? Because there are parts that
Yeah, that's exactly.
you could retrieve. Okay.
Yeah, that's exactly the point. That I mean, we are not yet there, Stefano. We are not that yet. I mean, what this is an exercise we are trying to do to see if it's actually useful and impactful to use this ethical label to describe as a further description of the product or the products. So if so, but this has to be discussed, so is nothing decided and approved. So if so, then we should also agree on how to show this, maybe in the metadata. Maybe in another format, but that's really an activity within the project. And in a way, we would like to discuss this also with the ethical board. But before discussing with the ethical board, we want to discuss within us. So that's the reason why we are presenting today.
Yeah, my question actually, Lily answered it partly now about how to use the label, and it's rather detailed. So maybe it has needs some kind of summary that really marks for the user which services could have a problem, and which are simply kind of green, like a traffic light.
This is actually, Henning, thank you for this, because this was actually the first reason we had in mind. So we have some products, we want to make some of these products, we make some of these products available publicly. So are there some of these products that might have an ethical issues attached? So how can we then identify this kind of products? And so that's why we started this exercise. And I think this is, I mean, we would like to ask for the community collaboration to first identify some products. But I think that the first, we start from products, of course, not from data. So something that is really, I mean, more advanced than the data, because the data is openly available, and so that shouldn't be. Although there might be some issues also on the data. Someone is saying that there might be some ethical issues also on, I mean, making the data available. But we are really thinking more about products and identified some products that might have this kind of issue. And today, you know, discussing also with also the comment that Stefano made before. So there are already some products that the Solidar Sites community is generating that I mean, are not publicly available. And so even if they are not public, is it useful for the community to anyway identify if they might have an ethical issue and which kind of issue, and so maybe work on these ethical labels, which is a proposal. So it's a first step. Is a proposal, as Giuseppe said, is built on another project in which they elaborated this kind of ethical label. And we thought it might be useful to actually try to see if EPOS can adopt this, but it's really, you know, something that we are exploring now in the framework of the project, and then discuss with the community and see how to proceed.
Okay. I think there are not any other questions. Probably the session is concluded.
Maybe a logistical I recall you to please go to the reception when you are you want to do it to take this passport for the dinner tonight, and also that after lunch there will be the group photo. And so, but who is where should we meet for the photo?
Perfetto.
Oh my goodness.
Sì, dai.
Okay, thank you. Thank you, Ellen. Questo tavolino là.
Sì, lo facciamo prima dell'inizio. Tanto io una volta che si dispongono scatto, faccio 10-15 scatti e poi li rimetto un altro.
No, loro lo devono sapere.
Beh, considera che nel...
Per la foto? Per la foto lo possiamo mettere dopo?
We can get them.
Let's make sure it's not hidden because it's broken. It's fine, okay.
Okay, so we
So
can
we
put
need
the
three.
next one.
Yeah, we can take them from around the area.
Okay, so this one we can move.
Yeah, on the there we can put them next to both.
Fai Fernando, è venuto. È Fernando, come sposti le sedie te? Come sposti le sedie tu non le sposta nessuno. No, ti potrà fare benissimo. Ah! Maybe you have done.
We got 26, really? So, if you have 26 and you start here, 1, 2, 3, 4, 5, 8, you may have the.
Oh, great.
Yeah, and then when it's converting to a proline state, after the program will start state. Yeah.
Oh,
Yeah, that's
okay.
Yes. 26.
If you and Fernando are going to stay on the stage,
Okay.
do you want to do that or?
No, we can repeat here.
Okay, after the group photo. You can put some chairs there. Mando after the group photo, we'll just put details here. Because in English, in English, you say we are for there's Elena, Elena, Lena. If it's a word. Yeah. After the flash presentation start, I'm gonna go. I think, yeah. I have to do a great lunch, but it's knowing YouTube that times two per time 1.25 on the video, you know, that's what we should do with you. Like, but no time, was it useful? So like, in most cases, not for create things that's not that's unbelievable.
like half an hour. Before
Oh, yes, but we
what?
every time the guys comes, we should sit in here and we should
Actually, look at that. There is the list.
ah
There is this here.
Yes,
It's
but,
amazing. One.
but the problem is that I don't see nothing.
I see it.
You can use this one. I can use my cell phone here and basically use the remarkable
Yeah.
here.
Yeah, I mean, it's gonna be good. Because I don't get with it from his with this screenshot. Yeah, it's okay. It's the first, it's the second.
One. Okay. Just listen good.
Yeah, we'll leave it here. For now.
We have time. 14 minutes.
Fine.
45 minutes.
One thing is this is a lot of time, and the second thing is it's a still group photo. I make the codes. I think they should not expire. But in case of anything, I also made the code that makes codes.
You should remember that you should that we have just 5 minutes. The timer.
Timer is here. Don't worry about it.
Okay. But and also because I don't know if it's possible to see an absolute URL.
No, it's not. It's for them. It's not.
Okay.
It's gonna be set here, so they see.
Perfect.
It's there now because the picture, the good photo. But then we will take it off stage, and they will be to see. When we are going to see, so we'll be like.
This is what yes.
Poster is there. You can put the exit poster and put in the area. Yes.
Ma te l'hanno per caso? Allora, te, facciamola.
Sì, perché noi, allora, io pensavo che stavano spiati magari perché lo piatto in centro. Sì, ma
Oddio, io ho pensato più. Insomma, da noi le cose sono. No, no.
l'ho mangiato nel piatto. Poi un'altra Sentiamo un secondo. Sì. Comunque a Filippo mi pare vedendo la slide up.
Sì, no, io ho messo più contrasti. Allora, col contrasto. Vedi, questo è più scuro. Invece il mio da qui, poco più di una lampietta, così secondo me no, poi facciamo quelle slide delle mappe.
Mentre vai il passaggio vado a tirare una nota.
Depending on how
Abbiamo messo più contrasto adesso.
Poi che non voglio fare spoiler. Infatti noi quando prepariamo le note, sul verde si mettono 15 note. Se no
Okay, everyone, if we could start coming up on the stage slowly for the group photo, that'd be great. If there are people still having lunch, if you could alert them. So please slowly start coming to the stage. I'll keep talking until I see people moving. So please start coming to the stage. If you're tall, come first. You know who you are. Yeah, Mark. If there's anyone out having lunch, please tell them to come in. They should be finished. And please come to the stage. Thank you. Thank you. Thank you. For people out in the corridor, I hope you can hear me. We're taking, yeah. Great. Yeah, exactly. The tall people first. Yeah. You know who you are. Yeah. I think we could move even a bit more back. Yeah. Henning. Oh, no, yeah, I meant Henning, yeah. Thank you, everyone. Yeah. Yeah. Let's see if we don't have enough space on the stage, some people can stand right in front of the stage. It's not a problem. Yeah, if there's no space. Great, everyone's still coming. And if we can't all fit on the stage, some of you can stand in front. Yeah, some can stand in front. Yeah. Yeah, you can start lining up in front. Exactly. Great. Thank you, everyone.
You're taller than me. Really.
Yeah. Okay, I think we're all nearly here. And I think everyone's here so we can. Don't worry, we have a professional photographer who can fit us all in. So, okay.
To go to the front.
All right, let's. No, we're going to change it in a minute. Yeah. All right, I think we're all here. Aspetta, Daniele, aspetta. Aspetta. Alessio, potrebbe mettere il slide tapo classico? Grazie. Oh, wait, we don't have Lily. Lily, get in the group photo. Wait. Yeah.
Oh, we should get them to hold her.
Right, throw crowd surfing. Okay, we're all here. We're getting our lights fixed. Okay, I think we're ready for the photo. Daniele is getting ready up on the balcony. That's going to be the flash. Okay. Okay, here we go. All right, here we go. All right, thank you. Thank you, everyone.
You here or maybe or we can see we can meet before the okay 7 o'clock. And where we have the game here? No, to work. Okay. For the best to meet at 7 o'clock the reception and we go together. Because we need to come here and go to the park. So
Poi vedi, quando... Guarda, vedi? Sara. Yeah, when you point here, you can see the
you
red
don't need to
button.
point there.
Yeah,
Perfect.
it points there. You see?
Yeah, perfect. So the top button, right?
Yeah, the first
Okay.
one.
Because soon I'll be here.
Yeah.
Okay, thank you.
So Asum is going to be in that video.
Oh, thank you. We have time. Still 4 minutes. Hello. Hello.
Imagine just rescheduling. The moment. Computer work.
Okay, we can start.
Yeah.
Yeah.
Well, it's 4 p.m. or no, sorry, 3 p.m. We are perfectly on time. Wanted to welcome you on the ECR session. It's first session that is held entirely by ECRs. This year we have been in charge for all of this. We will have 3 minutes presentations now of our participants. And please stick to time because we need to switch from who's on stage. And after that, we will invite you to the poster session. So let's start. Now I give my mic to Fernando.
Okay, good afternoon, everyone. My name is Fernando Monterroso. Just I want to call an area research the coming here because we are chair here for the early career research, please. We have more or less 26 guys, so please sit in here. It's much better for use. Okay, perfect.
One more thing. In front of you is going to be a timer, so you will be able to see how much time you have left. So you have to stick to that. And at least you will know when exactly it's time to finalize the presentation. Now we wanted to invite our speakers.
Okay, so the first person that we will start this session is Augusto Fonseca. Please, we can start now. Your time is done.
Okay. So hello everyone. Good afternoon. Okay. So I'm going to present about this work, Science Hazard Assessment for Northeast Brazil, which is a low seismicity region. This is the map of Northeast Brazil, which magnitudes are mostly low, but some with moderate magnitudes can cause significant damage. So this is an example of a 5.1 magnitude in 1986 that caused significant damage in a city nearby. And that elevates the reason of seismic hazard studies in this region. However, still, majority of the works, they are mostly based in country or global scale. So we used a regional updated catalog to delimit and characterize the seismic zones. We mostly used the episodes platform for it, for the episodes platform applications, for magnitude completeness estimation, for magnitude recurrence model as well. And we were able as well to estimate the magnitude recurrence for either in a parametric or non-parametric way, resulting in our first paper published, focusing on the processing of the catalog and the seismic hazard assessment of magnitudes, the source component of seismic hazard, and also using the applications within episodes platform, and also to characterize to analyze the probability seismic hazard analysis of the entire region for specific locations and as well for other cities, important cities, and developing the PGA map and comparing even with the current Brazilian norm, which we were able to reveal that some locations have even most higher seismic hazard values, compare even a triple of the expected value by the Brazilian norm. And also, some critical facilities might be experiencing overestimated, underestimated seismic hazard too. So this is something that I wanted to present it. And if you are interested, I would be very happy to discuss this later in the poster section. So thank you very much and see you.
Thank you, Jose. And now we invite Anna Tymińska.
Good afternoon, everyone. Let me talk quickly about near and intermediate fields in anthropogenic events. But first, I will introduce you 3 seismic cases, 3 episodes. First is Songteng 2 artificial reservoir in Vietnam. We have magnitudes, the biggest register magnitude there was 3.6. Next one is the biggest geothermal field, the geysers in California, with magnitude up to 4.2. And the last one is underground mine, Legnica Głogów Copper District, with magnitudes up to 4.0. So these 3 episodes are quite similar in meaning of the magnitude sizes. However, these are differences also. For example, in event station distances, because the Songteng has the biggest network, the geyser has both close and distant stations, and Legnica Głogów Copper District has the smallest network. Why I am showing you the event station distances? Because of some often assumption, which is the far field. We usually ignore the near and intermediate, but let's see how it looked like for anthropogenic cases. So for these 3 episodes, the results from amplitudes, displacement amplitudes, for Songteng, it's quite nice. Maybe we can include the intermediate field. However, for the geysers, we sometimes mistook half of the displacement for the far field. And in extreme cases for Legnica Głogów Copper District, the far field can be only 20% which is really, really small. The rest is near and intermediate field. And that's the only beginning, because we need to reorganize our methods, our tools to parameterize these events. But if you want to know what challenges we have to face for, I will warmly invite you to the poster. Thank you.
Okay, thank you, Anna. This next one is Magdalena Ponte, please.
Hi, everyone. I'm Helena Ponte. I work at LENEC, the National Laboratory for Civil Engineering in Lisbon, the capital of Portugal. And I work more specifically at the Earthquake Engineering and Structural Dynamics unit. I'm here because we are one of the facilities that uploads the data into BET database that Ripinho talked to you about yesterday. And just to show you what we do, because I know for most of you, this is not your field. So we have a shake table, and we do large-scale seismic tests on structures or retrofit solutions. And sometimes they even go to collapse, as you see. But from these tests, we don't obtain just these cool videos. We obtain a lot of data, and just to show you more or less what involves one project. So the Areas Freisus project, it was done and finished last year. So it takes more or less, it depends on the project, but more or less a year and a half. So half a year, it's for the project design. Then we go into construction of the model. It depends on the materials we use, of course. And then sometimes we even need to wait for their cure, like a month. We define the instrumentation. We have to define also the accelerations, the signals that we are going to input into our shake table, and to calibrate it to make sure that it really does what we want it to do. And then the coolest part is just more or less about a month. So the actual test, this was a base isolation system. We tested 3 configurations. And then we obtain our results. Usually they can be accelerations, displacements on the floors, walls, whatever part of the structure. We also obtain frequencies and mode shapes for the structure to evaluate its degradation, but also we use a motion caption system and cameras, videos, to record everything. So this part, again, it takes also a bit longer because we need to post-process the results. We're doing it at the same time as other projects. And then we upload everything that I just showed you. So from the beginning, the design part until the results, we upload everything in the BED database and where people can download. This is a very useful way for us to immortalize our data, also to organize ourselves, because sometimes it can get lost and outdated throughout the years. But we also receive a lot of requests of people wanting to access our results. And like this is so easy that it's accessible to everyone. Thank you.
Thank you, Elena. Now we invite David Shakhnazarian. The floor is yours.
Thank you. Thank you for presenting me. So this would be a nice follow-up to basically Madalena's work, and this is regarding the same candidate TCS, which is built environment data, and follow-up in the sense that it follows up basically the data, how is this data, how we want to use this data, what we want to achieve with this data. So essentially understanding and mitigating the effects of earthquakes for both structural and non-structural components. So some of the challenges without the experimental data being freely available would be to have empirical validation of analytical models that has already been shown, and based on that you can get fragility functions and vulnerability models for those components. And by those components, I mean not only the buildings itself, which is for sometimes one-to-one full-scale buildings, and also the non-structural components such as walls, electrical cabinets, servers, ceilings, piping systems, everything related to the built environment and everything inside the building. So how can we overcome these issues and how can we achieve these solutions? One way is to basically have a centralized database which is easily accessible and make these datasets publicly available and easily findable. So throughout the years, just to elaborate on those issues, there have been many experimental test campaigns that have been funded through European funding, as well as outside of Europe. And those are, some of them are defined here. And essentially, especially the projects that have been done before 2000s and even 2010s, it's really hard to find the data or find the people who have obtained this data, and those data have multiple publications, and some publications. It's basically a maze to find some metadata or data specific to a project or an experimental test, and then combine it and achieve some outputs like the fragility functions. So with this, basically with BED and as well as EPOS, we want to have a standardized quality assurance across service implementations, such as FAIR, basically achieving findability, good findability, accessibility, interoperability, and then we want to ensure long-term maintenance of those services. So with the previous projects, like I said, sometimes the data could disappear. With the long-term maintenance, we can keep track of those data and use it for the future generations. And we can have also increased, obviously with EPOS, we can have increased discoverability and reach a bigger research community and have some data exchange. So another opportunity to create a broader network of research and institutions across Europe. And this is basically it. Thank you very much. Hopefully this gives you some overview of the project.
Thank you, David. So the next one is Patrick Arnaise from Geosphere.
Hi, everyone. I'm mainly investigating the geomagnetic field, which is basically very important for us because it protects us. It protects us from cosmic radiation and the biosphere and the technical infrastructure on our planet. For example, we have this continuous flow of charged particles from the sun towards the Earth, called the solar wind, and the geomagnetic field is deflecting these particles and preventing them from penetrating into the atmosphere or reaching the ground. There are so-called solar storms every now and then, so strong events at the sun where these charged particles are intensified, and then they are deforming the geomagnetic field and penetrate the magnetosphere and can trigger geomagnetic storms. And these storms in turn then can cause severe damages for our technical infrastructure, mainly, or in worst case, blackouts in electrical power grids. So it's quite important to understand and to study such events, and we have the possibility using services and data provided by the EPOS portal. First of all, we have the direct measurements of these geomagnetic variations, which are provided by a global network of geomagnetic observatories. In this example, the Intermagnet network, which is providing standardized, high quality and real-time data to study such events. And based on this data, we can generate so-called event data and indices as provided by the ISGE service, the International Service for Geomagnetic Indices. And we also have now a Jupyter notebook in the portal with which you can produce plot like given in this example here. So what you see here in the top is the measurement of the geomagnetic north component at the observatory in Spain, Ebro. And you see that we have a quite normal behavior until a storm starts in May 24, which was actually the strongest event within the last 20 years. And you could even see aurora lights in northern Italy during this space weather event. At the bottom, we can use indexes, which are, for example, the KP index, which is a global measure of the geomagnetic activity. And as you can see, as soon as the storm has started, it reaches also its maximum values of 9, so reflecting very high and strong geomagnetic variations. So that's in some brief example about using EPOS to analyze such events. And I want to invite you to the poster to talk more about geomagnetic variations.
Thank you. We invite Diana Hristova.
Hello, everyone, and good afternoon. My name is Diana Hristova, and I'm a PhD student in National Institute of Geophysics, Geodesy, and Geography from Bulgaria. And today I will briefly present our work in building a magnetotheoric dataset for Sofia Basin. Okay, here you can see location of the study area. It's located in eastern part of the Sofia Basin in western Bulgaria, near to our capital, Sofia. It's a tectonic basin filled mainly with Neogen sediments, covers Triassic carbonate block. The structure of the basin is controlled by several major faults, which play important role in groundwater circulation and the geothermal system. Last year, 2025, we carried out a MT survey, magnetotheoric survey. Total of 26 magnetotheoric stations were deployed in the study area, and we tried to cover the most interesting geological structures and fault zones. As you can see, we didn't cover any in our southwestern part because there was a lot of anthropogenic noises. You can see the location of our magnetotheoric station with purple dots on the map. Despite this, we have some very good quality data. Here you can see our transfer function. In the upper plot present the apparent resistivity. The lower plot present the phase as function of frequency. The red and blue curves present the polarization XY and YX. And as you can see, they're relatively smooth and consistent, and this is a good indicator for quality of the data. And our next job is to perform a 3D inversion of the data. After that, we want to integrate it with existing borehole and magnetic data for better geological interpretation. And our final step is to upload the whole data set into EPOS platform and make it accessible for the whole community. And we hope we can do this until the end of this year. And that was from me. Thank you so much for your attention.
Thank you, Liliana. Now I invite to Oscar Reitman.
I guess you hear me because you do. This works, I guess. So my name is Oscar Rydman. I'm a PhD student in the Applied Geophysics groups at Luleå University of Technology in northern Sweden. And I will present, in a sense, the kind of mineral exploration use case then for the geomagnetic observers that Roman then presented or told you I would present today. So here's the payoff, so to say. Going forward, I'm going to be quite vague because my own research, I kind of fell into EPOS during my PhD studies. So my data was not from EPOS. But in mineral exploration, which I'm doing my PhD in, we often use many data sets. So it inherently becomes a cross-TCS endeavor. So for example, in my case, I've always used magnetotellurics. I've used airborne magnetics. I used gravimetry. And I've used geological information. all of these things we've heard a lot about from all these talks. So Roman talked about the geomagnetic observations TCS. We heard about gravimetry, that's a potential future things for EPOS. And we heard things about the geological modeling and the GIM TCS. So I made a little plot. I took an area of northern Sweden and I used the EPOS data portal to just visualize the data that was there and then take out what would be, so to say, potentially useful. And I hope in the future it will be, so to say, more useful, because at the moment, as we say, some data are not there, some data will be there, some data will not be there, but it will at least allow, so to say, future mineral exploration to be more easily manageable. So in a sense, what you would do is you would find available legacy data. At the moment, you are kind of trawling around, finding different sources. So myself, you find from the survey, you find from legacy data sets that are open, and then you find, well, I guess you have your area. You also gather your new necessary data. So you find your new for me, it was magnetotellurics. Then you do your little study. We do our little model. I guess I can use this to point. I myself make these little block models. In this case, both gravity, magnetic, and magnetotelluric. The data sets and potentially the models will then, of course, be published and afterwards made available on the EPOS portal, hosted on some kind of other service that provides a DOI, so to say. So that's kind of the use case in a sense. So, yeah, that's it.
Thank you, Oscar. Now we invite Maxime Labatut.
Hello everyone, I'm Maxime Labatut from BRGM, the French Geological Survey. Today I will demonstrate how we are bridging the gap in transboundary research by connecting BRGM research, virtual research environment, digital Earth into the EPOS platform. Our goal is to streamline the journey from raw data discovery to integrated scientific insights. BRGM is implementing an ambitious digital roadmap for 2023 to 2028 to advance geosciences through digital technologies. This strategy is built on 5 key pillars: fair data, digital twins, numerical computation and simulation, AI, and of course, virtual research environments. As the national leader in e-geosciences, BRGM manages major national databases and operates high-performance computing infrastructure. It also actively contributes to major European research initiatives, such as DataTerra, EGDI, and EPOS. Now let's look at the end-to-end user workflow within BRGM integrated digital platform. It all starts with step 1 data selection. Here the user interacts with our metadata catalog to discover relevant OGC services. By using specific filters like geographical area or thematic keywords, one can select the study area bounding box needed for the research project. Then in step 2, our custom aggregation tool is exposed within the Galaxy ecosystem, allows any researcher to merge the previously retrieved OGC datasets into a single unified file for cross-disciplinary study. Finally, in step 3, we reach the visualization and analysis phase. The integrated data is rendered on a single map, allowing the scientists to cross-reference different layers and generate insights through custom viewers and move to downstream data processing. To conclude, we have successfully moved from data discovery to scientific insights. Today, our system is cross-disciplinary ready and enabling hybrid data access where global EPOS layers meet local BRGM data and other interoperable data sources for seamless transboundary analysis. Our way forward is now to go beyond vector data. We are expanding to more complex datasets and services while focusing on unified access to progressively integrate. In short, we are building the bridge that turns raw geospatial data into actionable science. Thank you for your attention. Grazie.
Thank you, Maxime. So now I invite to Ricky Mamari, RVA GNSS.
Hello, my name is Fikri Babahri from the Royal Observatory of Belgium, and today I'm going to talk about my current investigation on GNSS jamming detection using EPOS data. So first, GNSS jamming refers to intentional or unintentional transmission of radio signal that preventing of GNSS receiver to receive accurate positioning and timing information. Detecting this kind of jamming is very important because now GNSS is not only used for navigation, but it is also used on a timing system, for example, on finance, communication, and emergency services, for example. For us, as a scientist, the implication is also significant because, for example, in EPOS, GNSS data are extensively used for geophysical studies. That's why in my poster, I would like to show that the EPOS GNSS data has a potential to play their additional role. Because today, the EPOS platform has provided access to GNSS data that are coming from more than 1,600 active GNSS stations across Europe. And with this dense network, we could monitor the jamming event based on GNSS observation. So at Aerobi, I'm responsible for developing the EPOS GNSS data quality monitoring portal, which serves as a front-end service to monitor the availability and the quality of EPOS GNSS data that are discoverable through EPOS platform. By doing this, we want to ensure that the EPOS GNSS data are accessible and reliable. Therefore, an automatic monitoring system has been developed to identify any potential degradation on the GNSS data quality and based on the indicator that provided on this web portal. And this indicator has been assessed previously to capture if there is anomaly on the GNSS data. And if there is any degradation detected, then the system will send a notification to me as operator, and then I will verify the issue. And then, of course, if I can, I also identify the root cause of issue, and then I will send email to the person who is responsible for the station. In this slide, I show one example of GNSS data quality degradation based on observation in a station in Estonia. And in recent year, I have observed many issues like this that caused by jamming. So due to limited time, I cannot go further into detail to explain you about it, but if you're interested, please join us in my poster session. Thank you.
Thank you a lot. And now we invite Ruben Carvalho.
Hello, everyone. So today I will be talking about improving offset accessibility. So an offset is like a discontinuity in the GNSS time series. So today we have two different solutions of offsets provided by two different analysis centers that are Yuga and INGV. And then we have already two types of offsets. One of them are the instrument ones related to receiver changes, antenna changes, firmware changes, and other stuff. And we have coseismic offsets from earthquakes. So we changed some labels in our plots. We put an eye at this image to represent the instrument offsets and an E to the coseismic events. And previously we have an R to receiver and an A to antenna. So at this moment we have integrated the offset service in the GNSS products portal, where you can search for marker, for a site name, for a country, so other stuff. And you can filter by analysis center too, and download the entire solution of the solution provided by the analysis center. So what are we doing right now? So we implemented an API and we adapted it to ensure compatibility with the ICS platform to integrate the service in the future. Well, the service already exists, just to download a JSON. But we want to integrate the service like we can see at that image, similar to the velocity service, so we can see the offsets at the map and the table. So that's it. I hope to see you in the poster session.
Thank you very much, Ruben. So the next one is Guillermo Grecchi, the Uniroma. Okay.
Hello, everyone. I'm Guglielmo. I'm a postdoc in engineering geology at Sapienza University. And today I wanted to present to you very briefly a new MSL field scale laboratory that was designed to study how sea waves actually interact with coastal slopes. But to make you understand why that's relevant, I'll just give you a few numbers. So if you think that Italy has more than 8,000 kilometers of coastline, and 2,600 of those consist of rocky sea cliffs, more than 4,000 landslides have been inventoried and documented on those. And so understanding how environmental and marine factors can actually impact these systems is essential for reliable landslide hazard and risk assessment. For this reason, 2 years ago, we landed in Ventotene, which for those of you who doesn't know that, it's a beautiful small island in the Tyrrhenian Sea that is bordered by steep sea cliffs for all its perimeter. And those cliffs are actively retreating at a very high rate due to the continuous pressure of sea waves in particular, but also atmospheric factors. And so we selected one of those cliffs to establish our field laboratory, which in this case, I would define it like dense monitoring network featuring a lot of sensors for environmental monitoring, for monitoring sea state and sea waves induced pressures on the slope, and also sensors for monitoring the stress strain response of the cliff. And all these sensors are connected to a cloud-based infrastructure for data transmission and sharing. So overall, these systems allows us to monitor and observe natural processes right where and when they occur, leveraging also the potential of great control on data quality that it's quite similar to laboratory experiments. And so, like, just to conclude, like, one of the key features of this laboratory that makes it one of the just few worldwide is the ability of monitoring sea waves and their dynamic impacts on the sea cliffs. In fact, by combining nearshore and onshore monitoring, we can actually investigate how dynamic impacts wave energy is transferred to the near shore, but also we can investigate how repeated impacts can contribute to rock mass damaging over time and eventually collapse. So that's all for me. So I hope you will have questions for the poster session. Thank you.
Thank you. We invite Mark Jefford.
Good afternoon, everybody. I'm Mark Jefford, a postdoc at Utrecht University. And first, I'll talk briefly about my role in EPOS, and then I'll talk about my research, which is looking at deformation in sandstone reservoirs. So within EPOS, I'm funded by EPOS Enlarge, which is the follow-up to EPOS NL. And this is an infrastructure project in the Netherlands, which is aiming to develop facilities which do research into the subsurface. They also offer access to these facilities through transnational access programs or national access programs. And so what I do on a day-to-day is try to improve these facilities, specifically the Rock Deformation Lab in Utrecht. I also help any visitors we have as part of these access programs. I'm also working as part of a team developing a kind of a new standard and tools for rock deformation data. So onto my research. So I'm sure we all know that the subsurface is going to be used a lot more into the future. We're going to have carbon capture storage, we're going to have hydrogen storage, we're going to have more geothermal. And all of this is going to involve injection into the subsurface or removal of fluids from the subsurface. And all of this has a risk associated with it. For example, in the Netherlands, we have a nice case study, well, not a nice case study if you live there, but basically they took out a lot of gas from a gas field since the 1960s. This is the Groningen gas field, and then it caused a lot of earthquakes and subsidence, as you can see in the top left figure. And what we try and do in the lab is relate this to rock properties such as porosity or the pre-existing fault network, as you can see on the right. And so what actually is a rock deformation experiment, in case you have no idea? We get rocks. They can either be kind of from the surface or from a quarry, or they can actually be from the core material itself that comes from a reservoir. We make nice little cylinders from it, and then we place it into a machine where we deform it at the pressure and temperatures which are kind of representative of the subsurface. And then we measure to see what happens. What I'm particularly interested in at the moment, and my poster is about how cyclic deformation and constant cycles of, say, injection and removal of fluid would impact the deformation. So, for example, here I've got 3 different experiments. On the x-axis, you have strain, which is a measure of how much something has deformed. On the y-axis, you have stress, which is how much force I'm squashing it with. And we measure kind of how different amount of cycles and the amplitude of these will cause deformation. And if you want to find out more about the results, come and find me at my poster. Thank you.
Thank you, Mark. So the next one is Simone Francesco Fornassari for University of Trieste.
Okay, good afternoon, everybody. I'm Simone from the University of Trieste. And the work that I'm presenting today is focused on the NITRO Near Fault Observatory, and in particular on the evaluation of the feasibility of earthquake early warning at this Near Fault Observatory. The area that is interested by this Near Fault Observatory is characterized by low to moderate seismicity. Although this can cause some damage that are usually within 50 kilometers from the epicenter. The first step of this analysis was to monitor the data latency from the 34 accelerometric stations that are part of the virtual network of NITRO. And this allowed us to, can I point somehow? Okay. This allowed us to evaluate the latency from each station. Merging all this information together, we ran some numerical simulation considering all the different sources of latency. And we evaluated the performance of the system that was based on Presto as an early warning framework in terms of the blind zone extent and the lead time at specific locations. The results of this simulation were corroborated with offline testing and later with online testing of the system. And the results suggest that the effectiveness of earthquake early warning in NITRO at its current status would be limited, as at least 50% of the damaged sites would always fall within the blind zone in most scenarios. Although the results suggest that there are several ways to improve the performance of the system, and for anyone who's interested in the details of the analysis, please come find me at the poster. Thank you.
Thank you. Now we invite Sara Moscarillo.
Good afternoon, everyone. I am Sara Moscaritolo, and I'm from
the university. I'm the first year PhD student at the University of Naples, and I'm here to present my work on the ambient noise interferometry for shallow structure characterization at the European Near-Field Observatory. The data used for my analysis are completely available through the EPOS infrastructure and come from the ZK network, which includes 20 arrays and 200 stations, and densifies the ordinary and long-term network used for the seismic monitoring analysis at the European Near-Field Observatory. For my analysis, I've selected about 7 months of data recorded by the array 09, highlighted in yellow on this map. And I used the software NoisePy to apply the interferometry technique, which allows for the reconstruction of the Green's function between each station pairs by stacking over the entire period of analysis daily cross-correlations of seismic ambient noise continuously recorded by station pairs. This cross-correlation can exhibit different arrival times of the signal in function of the interstation distance, but they can also exhibit a very different signal-to-noise ratios. So for this reason, I have applied an SNR-based selection criterion to exclude those with very insufficient quality. And in this way, it's possible to obtain more stable Green's function between each station pair, and it's possible to clearly observe the Rayleigh wave propagation velocity from the stack plot, in this case, in the frequency band of 2-4 Hz. Starting from these results, the next important steps will be to compute cross-correlations between pairs belonging to different arrays and explore different frequency bands to proceed with the extraction of the Rayleigh wave dispersion curves from stacked cross-correlations and make the inversion to obtain near-surface shear wave velocity structure and have information about the elastic properties of the medium in the shallow layers. Finally, it will be also interesting to investigate about possible seasonal variations in the area. So I invite you to my poster if you would like to discuss my work in more details, and I thank you for the attention.
Thank you, Sara. So the next one is Francesco Scotto di Uccio, the Università di Napoli.
Okay, so good afternoon, everyone. I am Francesco Scotto di Uccio. I'm a postdoc at the University of Naples, here representing the TCS NFO. And in this flash presentation, I will discuss about the possibility to enhance the resolution of the microseismicity, which is the only seismic evidence that we have during the interseismic time of large earthquakes. So actually, we will focus on the area that is now monitored by the European Near-Field Observatory, which offers different observation scale from the kilometric scale of the permanent infrastructure down to the decametric scale offered by 80 kilometers of fiber optic sensors using a seismic sensors, actually. And in this presentation, we'll focus on actually an intermediate scale that was offered by the temporary deployment of 200 stations deployed in 20 arrays, as Sarah shown before in the former presentation. But this time we will focus actually on the earthquakes rather than noise, and in particular trying to understand whether we can generate enhanced seismic catalogs from advanced techniques, and actually what information we can use and we can infer from these deep catalogs. So the EPOS data portal offers different standardized waveforms coming from different observatories, and this allows us to develop, test, and apply advanced techniques. And actually, we propose the integration of machine learning and similarity-based techniques to enhance existing catalogs also by an order of magnitude. And when we export this strategy to the data recorded by the dense array experiment, we identify in just 1 year almost 3,600 earthquakes. That is a number comparable to what we observed from 12 years of seismicity coming from the longest term infrastructure. And when we determine the epicentral coordinates along with the statistical parameters of the frequency magnitude distribution, we observe coherency both into the hypocenter and the activated area and also in the statistical properties. Therefore, we can downscale the statistical properties on a shorter spatial temporal scale. We can also improve our knowledge on the fault properties because we can therefore resolve the focal mechanism that give us information of the orientation of the fault planes, and integrating arrays and machine learning techniques, we can decrease the threshold for getting this information down to magnitude close to 1, and we can reconcile all these results into the direction of seismic hazard by integrating these results with tomographic section, and we can identify potential earthquake-prone structure that can increase the seismic hazard in the area, and we can validate this through numerical simulation. So there are many other messages that I would be glad to discuss with you at the poster session, but the main message that I would like to deliver is that we can improve the comprehension of the seismicity using enhanced catalogs. And as community, the next step would be to flow these catalogs into the EPOS data portal, and then to create some automatic end-to-end workflows for continuous monitoring on one end to increase the content of the catalog on the portal, but also to respond as a community in a homogeneous way to then the next earthquake that will strike in the future. So thank you, and eventually see you at the poster.
Thank you. And our floor is given to Claudio Strumia.
Thanks for the introduction. Good afternoon, everybody. I'm Claudio Strumia from University of Naples, representing the TCS NFO. I'm a postdoc researcher here working on distributed acoustic sensing. And today I will talk about our recent work on exploring the potential of DAS for earthquake early warning. And as many of you may know, DAS is an optical technology that allows us to transfer fiber optic cables into really dense arrays of strain meters. So it gives us a new way of looking at earthquakes, and it has a lot of interest for the seismological community. Its potential for earthquake characterization is now quite well established, but we are interested in understanding whether we can monitor in real time for earthquake early warning. And we are doing that in two different environments. First, within the Irpinian Near Fault Observatory, as you can see here. And here with fibers on land, we are interested in understanding whether the high density of station close to epicenters can increase our resolution on seismic source characterization in the first seconds after an earthquake is detected. And then we're moving offshore with cables offshore central Chile. And here there is a great interest for earthquake early warning with DAS because cables that run close to seismogenic sources like subduction zones with respect to on-land station can give us tens of seconds of gain in the lead time available for issuing alerts. So we are developing a framework to integrate DAS data within established earthquake early warning system like Presto, as you can see here. That is also under testing within the Irpinian Near Fault Observatory and operational in other near fault observatories like the Francia one, as we have seen this morning, and also is integrated within the EPOS universe through CREW, the European Center for Earthquake Early Warning Testing. And so, as a DAS data user, thanks to EPOS, I can access seismic catalogs and continuous waveforms that allows me to interpret and analyze parallelly DAS data, but also with the development of the technique, we now also have shared robust processing packages for handling this data. And also we are starting to see the availability of decimated DAS data streams. Still, there is a big challenge in working with DAS data to do the massive amount of data that impede from the sharing of full resolution DAS dataset. And also we need community shared standard for metadata, for instance, and possibly cloud computing platforms that would allow for easy processing of this large and massive amount of dataset. But still, I have to say that from yesterday's presentation from the TCS, I saw that there is a lot of effort in this direction. And so I would like to thank you for supporting our research and for the attention. And if you have more curiosities, I would be glad to answer at the poster session later. Thank you.
Thank you, Claudio. So the next one is Tommaso Castelvarco of University of Milano.
So good afternoon, everyone. And in this presentation, I'm Tommaso Castelvarco from the Milan section of the NGV. And in this presentation, I will show you just an example of how EPOS can help me in my research activities. In this particular case, I'll present you the record selection for seismic microzonation studies in the Campi Flegrei area. The Campiflagari area is a caldera area that experienced over 25,000 events between 2011 and 2025, and due to the reactivation of the Bradyscenes phenomena. So in this context, level 3 microzonation study was launched for the municipalities involved. And for this, it was necessary to select spectrum-compatible accelerograms for numerical analysis in order to evaluate the local seismic response. And we also estimated the empirical amplification factors for the temporary and permanent stations in the area. These network accelerograms that we selected are available in several databases, such as ESM, and can be selected using tools as RexaWeb, that is the one that we used. And they are also accessible through the EPOS portal. In this slide, I'll show you just in brief the workflow. So we choose the best ground motion model for the area, which is a volcanic area. We defined the reference earthquake and the reference site class. And then we did the actual selection on using RexaWeb. The selection is shown in the graph in the middle of the slide, and these waveforms that we selected are available, as I said before, through the EPOS portal, as we can see in the screenshot on the right. Another product that we use is the ESM flat file, which is also available through the EPOS portal. This is a parametric table that contains the metadata and the intensity measure of manually processed waveforms recorded by the accelerometers. And these recordings can be used to make comparisons, like in the graph on the right, between the ground motion model. In this case, we use the LL19 ground motion model, and the recordings that are shown as the red points in the graph. This is for the recordings are from an event that occurred in the Campiflagari area with the magnitude of 4 and an EPOS interval depth of 2.5. And thank you for your attention. Obviously, I'll be at the poster session if you are more curious.
Thank you. We invite Nikos Hadzis.
Hello all, my name is Nikos Hadzis. I'm a postdoc researcher, and I will present you the automatic processing of strong motion accelerometer recordings for earthquakes in Greece. And the main purpose is to compute automatically ROD 50 values of peak ground acceleration and pseudo spectral acceleration spectrograms. Well, actually, this is within a project for the compilation of a new seismic hazard of Greece. So we analyze automatically raw accelerometer data to remove the noise from then to compute the displacement time series, then the PCA spectrograms, but it's out of the study, to calibrate CMP's equation. And so for this reason, we use a dataset of 155 shallow earthquakes, magnitude equal or greater than 5. We use a catalog for the past 10 years. We used all the available stations from the ITSAC and NOAA stroke motion networks from Greece. Also, we use several stations from the AFAT network from Turkey for earthquakes located close to Greece-Turkey borders. And the methodology includes the automatical detection of the earthquake signal using machine learning algorithms, the automatic identification of the reliable frequency path of the seismic signal. For that reason, we use a signal-to-noise ratio approach following Mascandol et al. And then we compute the acceleration, velocity, and displacement time series. Here, I'm sorry. Okay, doesn't matter. Here only the velocity and displacement are given. So about the results that I'm going to show you, I will show you a typical example of PSA pseudo-spectral acceleration curves for a single case of its component earthquake record. The BJ ROT50, as well as the PSA for 1 second versus episodic distance, here on the top and bottom respectively, for the whole dataset. Thank you very much, and don't hesitate to read my poster.
Thank you very much, Nico. So the next one is Marta Freddy from University di Camerino.
Hello, good afternoon, everyone. I'm Marta Freddi from the University of Camerino, and I'm also a collaborator at the INGV in Milan section. Today, I will talk about ground motion variability. So when we talk about empirical ground motion or strong ground motion data, they have many advantages. For example, they are validated by definition, and they usually follow community standard. On the same page, but we need to think about that they are sometimes limited in the near source region and for large event recordings. And for this reason, we can use synthetic data. In fact, the synthetic data can fill this gap because it's possible to control the scenarios, but the cons is that they need the validation against observation, and they also have sometimes a quite challenging standardization format. So my study investigates the ground motion variability and its main contributor using a synthetic broadband database for normal fault scenario in central Italy. And we use a restricted dataset to keep the variability consistent with the empirical one. The idea is to study ground motion and analyze it with the linear mixed effect regression, and residual are then decomposed into a between and within scenario component, further examining across frequency and space to try to interpret the dominant contribution. And then we focalize our work in the remaining residual part to try to identify effects that are not captured by the model, for example, the directivity effect. And this detailed analysis can help my work, my future work, to try to create a new set of simulation to investigate variability in a more systematically way. And obviously, I will need a validation for the data, and I will use some product of EPOS, for example, the Engineering Strong Motion database for the validation, or the European fault source model to define the fault geometry. And the main goal is to try to support an hybrid empirical and synthetic development, so try to use all the data that we have. Thank you, and see you at the poster session.
Thank you, Marta. Next speaker is Hakan Süleyman.
Good afternoon. I'm Hakan Süleyman. I'm a researcher at Query of Boğaziçi University at Istanbul. Today I will be presenting our GMP development efforts, particularly for Istanbul, that we developed by using both observed and ground motion and simulated ground motion data. As many of you know, Istanbul is closely located to the North Anatolian fault, which roughly appears around here. For this study, we utilized around 170 stations, and I can say it's around 3,000 recordings, ranging from magnitude 4 to magnitude 6.1. As you see, the city is as you know, is prone to high seismic activity, and this fault line is capable to generate high magnitude events. We only have a few data above 6.1, which is the 1999 Marmara from the 1999 Marmara earthquakes, and we tried to fill this gap by using ground motion simulations. In the next stage, we used two ground motion simulation approaches, a physics-based simulation approach and a stochastic ground motion simulation approach to develop synthetic data. These techniques were validated for the Istanbul region by utilizing data from past events. And we developed this synthetic data set by also by developing 18 scenarios ranging from magnitude 6.05 to magnitude 7.6. And in the end of this stage, we developed broadband simulations by merging the results of these two simulation techniques. In the last stage, we developed three ground motion prediction equations. One of them is a conventional GAP developed by real ground motions, covering the magnitude 4 to 6.1 range. The second one is a machine learning enhanced GMP developed for the same data set as we used in the initial model. So basically, it's just an enhanced model, a variation of the first one. And the last one is a synthetic only GMP developed for the magnitude 6.05 and 7.6 range. Thank you for your attention. I would like to see you at the poster session.
So the next one is Alice Abate from GFS.
Hi, everybody. I am Alice, and I mainly work with quantification of uncertainty in PTHA. So let's unpack first this acronym. PTHA means probabilistic tsunami hazard analysis. There is an established workflow consisting of mainly 4 steps to do so. So the definition of earthquake scenarios, the tsunami generation and propagation, the aggregation of outputs with scenario rates, and finally, the computation of hazard curves. So hazard curves are the final product of an hazard model, and for me are actually the starting point to go in reverse. Because by means of disaggregation, we are basically able to extract a synthetic catalog of magnitude and hypocentral location that can populate seismic source zones. And we are basically able to define new scenarios. Now, the main question here is how much alternative model choices might impact tsunami metric and hazard results. What we mean by alternative choices, we mean alternative choices in modeling. So we are at the stage of epistemic uncertainty. Such alternatives might be related with the definition of the slip, for instance, or with the definition of the rupture geometry, according to alternative scaling relationship. But we can also dig into the aleatoric uncertainty by, for instance, exploring the variability of scaling relationship itself. So once we construct this database of perturbed scenarios, we can propagate tsunamis and compute high-resolution inundation simulations, and finally, or offshore tsunami metric, and we can finally quantify basically how much this uncertainty impact our results. I will not dig into results here, but I will say that this work is undergoing through a TA, a transnational access in the project GeoEnquire, for which I am the PI. And such outcomes will be available on the simulation data lakes in Sineca. Thank you very much, or grazie mille, for your attention.
Thank you, Alice. Now we invite Naveen Raghu Ramalingam.
Thank you, Helena. Good afternoon, everyone. In the next few minutes, I would like to talk to you about submarine landslides and the tsunamis they generate and the workflow we are developing in modeling them. Submarine landslides and the tsunamis they generate, I mean, it's an important source of tsunamis, but underrepresented. They have a lot of impact on our coastal infrastructure. If you think of the development we are doing in terms of infrastructure, submarine cables, pipelines, offshore installation, these could be renewables. And so the consequences on these are that these events, submarine landslides, they happen very close to the shore. They have short travel time to your coast. If you think of it as a geological process, you have evidence of like a few tens of events across an ocean, but you would like to model them across the ocean. So what can we do to solve this problem is that we try to use data sets from more regions, but also complement our workflow with numerical modeling. So here's an example of a workflow that we're working on. Basically, it uses inputs like bathymetry. We constrain it with information on the slope. We develop a mesh, and we try to model different kind of scenarios. We try to sample in different volumes that can cause submarine landslide. The idea behind is you explore the uncertainty through something like a logic tree. You play with the volume, the geometry, the different dynamics that's possible. And in general, the process looks something like this. Once you run the workflow, you can come up with tens of thousands of events that can happen on a slope. This looks very similar to the slip modeling that traditionally we do for earthquake sources. But you still have too many events that you cannot explore or model all of them. So we try to cluster them, reduce the number of events that we would like to evaluate. So basically, we pick out things like volume, the type of failure that can happen, the location, and we try to find the best set of events to evaluate. How do we evaluate these is through numerical models. These are things that in the tsunami TCS community, we have models and we use. So there are two examples here for the submarine landslide runout modeling. We use BINCLAW. For tsunami wave propagation, we use something like tsunami high sea. The idea is you can model these, but how do you constrain them? You need information to reduce the variability that you want to test. So data sets like the European Mediterranean submarine landslide catalog is super useful. It's not for India, but you can still use it to constrain the kind of things, the volume, the empirical relationships you need to build such a catalog and model synthetic events. Basically, I would like to summarize this into the fact that in our community of Tsunami TCS, we are exploring these two avenues that I use as a user, the tsunami data, like the submarine landslide catalog, but also the numerical models. But as a developer and a researcher, I see the outputs that I create can also go back into the EPOS data services. Thank you. And if it's interesting, I would be happy to speak to you in the session.
Thank you very much. So the next one is Syed Sabtani from the University of Naples.
So good afternoon, everybody. Today I'm presenting from PTHA, what Alicia present now, to probability of the safe evacuation and how we can consider it as a use case for ICSD in EPOS. So perhaps no one or very few remembered from last year that I present my first ABM evacuation modeling using the limited tsunami scenarios and one example for safe evacuation percentage for a specific scenario in Catania that you can see also the results from last year here. And this year we extend the idea to present as a fully simulation-based risk assessment or kind of the PTRA using multiple PTHA plus multiple agent simulation to give a probability of safe evacuation. And for more information about the PTRA, you can also check the cookbook from TCS Tsunami that I also show the reference here. And the ultimate goal for for this work is to have the digital twin for evacuation, or what I call the next generation tsunami evacuation framework. And the automated Jupyter notebook that I mentioned here can be useful to have a scalable tsunami risk assessment and support the transition from this agent-based modeling to a digital twin for evacuation. About the simulation-based tsunami evacuation risk assessment, the core idea is that the agent-based simulation can be interpreted as a Monte Carlo realization of evacuation simulation under the uncertain conditions. And at the end, the results can be averaged and considered as a probability of safe evacuation that you can see the formulation here. And what I show here is exactly what I said. So you can see the multiple tsunami scenarios, hazard scenarios, and also multiple scenarios for physical and human exposure modeling, and also the scenarios for behavior uncertainty. So we can consider all of these frameworks as a Jupyter notebook for agent-based tsunami evacuation modeling that I showed here. So we have 4 different Jupyter notebooks that can be evaluate what we need for agent-based tsunami evacuation modeling. For example, you can see here the first Jupyter notebook for hazard modeling that can has the data from the simulation data lake that Alice mentioned. And using the importance sampling, we can output these scenarios as a tsunami hazard layer for our agent-based modeling. Or for example, also we have other Jupyter notebooks that there is no time to mention it for the moment. And here also you can see one results here and some key takeaways from this presentation that these Jupyter notebooks can automate the tsunami evacuation simulation modeling, and multiple scenarios generated by these GNs can be used for fully simulation-based public tsunami risk assessment. And also, at the end, this ABM can be a key step toward the digital twin for simulation evacuation. Thank you very much, and see you at the poster session for more information.
Thank you. Next one is Alessia Patane.
Thank you, Elena, and good evening, everyone. I'm Alessio Patane from the Institute National of Geophysics and Volcanology in Catania. I work for the thematic core service of the volcano observations. Today, I'll briefly talk about how I enhance the access to volcano observation data. So briefly, what I do in EPOS is to develop a web service for the volcano observation thematic core services and ensuring that they are EPOS compliant, and I make it accessible using some web frameworks using RESTful APIs, and I build the data expression tools to make use of this data and enhance the access for researchers to visualize it on the fly. And lastly, I support this with the visualization with web portals. One of these is the volcano observation data portal that I recently developed, where user can easily access to different kind of categories of these thematic core services. As you can see, there is also a query builder and a quickly visualization tool, where here in this data portal there are also EPOS compliant web services, but also EPOS not compliant web services. And talking about the services, the one that recently developed and integrated was the stream meter data Italy web services that is integrated both on the Vault TCS data portal and in the EPOS platform. And then one tool that recently I added into the data portal was this geoportal for static and dynamic hazard maps that basically it's not just a viewing tool to visualize hazard maps, but also to make spatial queries for the services that are providing hazard maps basically on different kind of geohazard. So users or researchers can access to different kind of geohazard informations. So thank you, everyone.
Thank you very much, Alessio. So the next one is Maddalena Dozzo.
Thank you for the introduction. Good evening, everyone. I'm Maddalena Dozzo from INGV of Catania, and I'm a third-year PhD student, and my project mainly focuses on the identification and quantification of sulfur dioxide from volcanic sources, especially using a Tropomi satellite, which is a sensor that is available from 2018. In particular, during my first year of PhD, I focused on the use of Google Earth Engine platform, which allowed me to extrapolate the entire time series from 2018 to date of SO2 total masses, since it is an open source platform, and that allowed to extrapolate at potentially global scale in near real time masses, but also fluxes of sulfur dioxide. The main limitation of this platform itself is the fact that it only contains one height at 15 kilometers. And so to try to fill this gap during my second year of PhD, I developed another algorithm using Python to retrieve using a wind dataset the plume altitude. And in particular, I use exactly the wind dataset from ERA 5. To compare the altitudes I retrieve, I use the EPOS data, in particular the VONA dataset, that is the Volcano Observatory Notice for Aviation, provided by my institute. And one possible suggestion to EPOS communities to integrate the wind dataset that is very important for flux computation, but also for mass computation. These are some references. In particular, the first one is the paper published regarding the Google Earth Engine work. And thank you for your attention, and see you at poster if you are interested in my work.
Thank you, Maddalena. Now we invite Francesco Spina.
Hello everyone, I'm Francesco Spina, PhD student in computer science at the University of Catania and also a research fellow at the INGV of Catania. Here in brief, I will present my work titled Semi-Supervised Learning Applied to Multi-Source Satellite Data for Volcanic Activity State Classification, and in particular I focused on the case of Mount Etna in a time window that spans from 2005 to 2008. In my work, I used many type of satellite data, very different type of data. In particular, here you can see, for example, radiance data from MSG satellite, ground displacement from Envisat satellite, LST and surface temperature from Aqua and Terra satellites, SO2 flux from Aura, and in the end, gravitational anomalies from Grace satellite. The idea is to give as input all this data to my deep learning model. In particular, as you can see here, I implemented a semi-supervised gun model that gives as input both labeled and unlabeled data, because in particular when you want to implement a classification model in for example, volcanic studies, the main critical point is the manual labeling of the data, because as this is time consuming and prone to errors. So here the idea is to use both type of data, so a small amount of labeled data and a large amount of unlabeled data, to train the semi-supervised learning model in order to reach high performance with a few few labeled data sets. So the last slide I will discuss regards the data availability. In particular, my research uses only satellite data. EPOS provides Sentinel-1 in SAR, but it does not cover the time window spans from 2005 to 2008. The required MBSAT in SAR data are not available on the platform, but can be had from other platforms, for example, Etna Supersites. And other datasets I use, for example, Severi, Modis, Somi, and Grace, are not integrated in EPOS. Thank you for your attention, and see you at my poster for more details.
Okay, thank you everyone for so much sticking to the schedule. We are ahead of it now because everyone was so on point with the presentations. I wanted to add some stuff because we've been working on getting for early career researchers some kind of access, the early access to EPOS services. We work on that still, but if some of you is interested, please tell us so we have you in mind while we get some information about that. There is no promises yet, but we try our best to get that. Since we are ahead of schedule, I think we can have a short break before we go to the poster session that starts at 17. I don't know, Fernando, want to add something?
Thank you very much, just now.
Thank you.
But I would like to make a comment. You should have learned so far. No, a comment, but I need glasses and light. So first of all, I would like to really thank the chairs and thank all of you for attending this week and for presenting your research. I hope, our purpose in inviting you to come to these EPOS Days is not only for you to present your research, which is very important and we appreciate, but also because we hope that staying 1 week with all these other colleagues, you have an idea what does it mean these days to do research. So it's not only to deal with data and look about what your work can, which challenges your work can address, but it's also everything is behind doing this. I'm not telling that you have to do it now, but just that you are actually aware that this is the way in which research works in these days. And so I hope that these days are useful for you to be into the mechanism. From your presentation, I have seen many different examples of how the data on the EPOS platform can be used. And so thank you for those of you that are already using the data on the platform. A lot of example on how your research can actually contribute to make the EPOS platform richer and richer. That's very good. Also important to receive feedback. I don't know who now. I don't see who said this, but
something to add about that, if it's possible now. Can I throw my comment in it?
Sorry?
Yes, we will have a feedback forms tomorrow before the beginning of the day. We will make some slide with QR codes for ECRs and for participants of EPOS Days, so you can help us get some feedback from the session, from our session. That was a moment ago, so it will be very helpful for us if you feel it. It's going to be in the morning, so after this session ends and everyone can have some time to think it through, we will be grateful for your feedback.
Okay, that's good, but I haven't finished. Sorry. It's also important to receive feedback on which kind of data you are missing from the platform. This is very important for us. So that was very important. And I also I think it's also important to see that with your research, you are already feeding the next step of the EPOS platform, the ICSD, so all this data that you are using to do these Jupyter notebooks. And I have finished, so I don't know if Elena and Fernando have...
No, you reminded me in
Okay.
the middle of your talk.
Okay.
I'm so sorry to interrupt you. Thank you for letting me do that.
Thank you, everybody.
Thank you a lot.
Goodbye.